Like now?
Like now, right now.
That sounds like a good time.
Right now?
Good morning,
Yeah.
everybody.
When is now?
Now.
Now.
Good morning, good afternoon, good evening, and good night. Thanks
That
to
is
Twitter.
true.
That's right. Welcome to the broadcast. We're going to do an hour and a quarter of time on setting up your systems, answering early questions, and general banter about weird things. That's part of our trademark. We have to talk about weird things.
Mm-hmm.
Are you referring to me, Bill?
Mm-hmm.
I was not adding any names to that. I'm just saying things.
No.
Okay. Okay.
Hmm?
Betty Crackus has come here for the pre-show banter specifically. No pressure. No pressure on us too.
Yeah. We were thinking about doing
Witty.
a webcast that was nothing but pre-show banter. And then right at the end, we would switch over to the post-show banter where we go over the pre-show banter that we just had.
Yeah.
That sounds amazing.
Someone
And
did
we'll-
tell me one time that that's just Security Weekly.
Yes, it is. Without the alcohol and cigars. Yeah.
Yes.
I bet you anything. We would have 50 people sign up for that. I bet you anything.
Only 50. A Patter Show 68 ask a good question. Who am I seeing online top to bottom? So what we see is different than what he sees. But it's always a reminder that we need to introduce ourselves.
Oh, yeah.
Some people don't know who we are.
And it doesn't show our names.
It does on mine, but that may just be because I'm a presenter.
Right. We get to see the names, but no one else does.
Okay. Yes.
So I'm Bill Stearns. I'm going to be doing the presentation today. Over to
I'm Jason Blanchard. I help with the content community for Black Hills Active Countermeasures and Wild West Hackin.
I am Deb Wigley. I do the same as Jason, help with content community. I don't know who's next.
I don't know what order we're going in, but I'll say I'm Ryan, and I'm doing all the video editing and occasional shit posting.
The weird
I'm
flex.
Naomi, and I'm a software engineer for Active Countermeasures.
Awesome.
Awesome.
Thank you, everybody, for taking part today.
Well, sorry for the rude interruption. Please carry on.
Favorite passwords.
Hollywood
Well,
Squares.
we did an introduction, and so we just finished. So now this is Keith. Keith is here.
Okay, here I am.
Keith, what are you doing today? What role are
A
you
little
playing?
bit of everything. I was just kind of actually just before I jumped in here, I was kind of playing around with some different methods to deliver malware, primarily using DNS over HTTP. So,
reminds me of- That reminds me of
Another Tuesday.
one of my favorite talks that John ever gave was on if I woke up evil.
Mm.
If
And,
Yeah.
and
Hey,
it
Sam.
really, yeah,
hey, Sam's here. Well, it's
Good morning, everybody.
nice one, Captain.
Velda. Hey, Velda.
Hey, how are we?
We are good. We
I
are
feel like
good.
this is about. Is this like a party line? It feels like a party line.
It is a party line, total party.
Yeah.
We're good.
Remember the 90s? They had the party lines like call now and meet singles in your neighborhood, and it was really just like 25 dudes. Just hello.
yeah.
well, there were singles. There
How
you go.
How is that us? How is that us? I don't get.
Well, there are only 6 of us, but
I say things to get a reaction from the Discord audience. That's what I'm doing. For those of you that are from other parts of the world who don't know any of these topical things due to the fact that you're in other countries, thanks for being here today.
You can see me. I was like, can you guys see me?
No.
No, we can't.
Black square.
there's a Phantom Velda. Where's the Phantom Velda?
Did we reach our max?
You know what? I'm just going to turn me off and just watch you people.
No. Try again. Don't give up. Don't give up.
Come on.
What's the max amount?
I don't know. It's not going to let me share my cam, guys.
Oh, you have the wrong role, Velda, somehow?
It says your webcam is already in use. Please close all other applications and use your webcam. And try again. Should I just log off and log back in?
Sure.
Yeah, try turning it off and turning it on.
Someone said malware successfully delivered. Well done.
I can try logging off and logging on again.
Wasn't me.
See you in a minute.
Oh, okay. Let me clear up something for all the hundreds of people showing up. This is not the workshop. If you create an account in Discord, please verify your email address, because if you do not, you're going to have a bad time the next time that you want to use it. And then the other thing, too, is that once you get into Discord, you have to wait 5 minutes before you can post. That is a security measure on our behalf. We had an issue with a pornography bot one time, and I had to go in and clean it all up. And I still, when I close my eyes, I can those images. So we put those things in place. So,
You haven't made it until you had a pornography bot invade your server.
I haven't made it.
Yeah.
So which OS do we need to set up? I see this one.
Windows 95.
Windows Vista.
Who said that? Who said that?
Yeah.
Yeah. I take your Windows 95 and raise you to Windows Me.
Oh,
Man,
You remember that curve?
I do.
Bitcoin. I got in on Bitcoin was about 15 grand a Bitcoin, and then I sold at about 9 grand. So
well,
I don't think you're doing that right.
that buy high, sell low strategy is just not what you want to do.
I've been buying high, selling low my whole life. That's
So if you've got questions, again, you can use the
Radio Shack has answers.
That's right, it does, except they're out of
Did I
business.
say that out loud?
I know. Was that the outside voice?
all right.
Camera works.
Welcome back, Zelda.
Hey.
We can see you now.
Everybody, this is the deputy. It is Zelda. So if you've ever gotten an email, show us your cat. The cat comes when the cat comes. It's a cat.
It's a cat. Yeah.
Florida, Maryland. That is where we are at. Some of us. Two of
California,
us.
Sweden. Oh, wow. That's a name I cannot pronounce.
Utah.
Mexico, Indonesia, Orlando. I live in
Hershey.
Orlando.
Hey, Orlando.
I found a
Maryland,
comic
Nick.
book store in Orlando.
Oh, Fargo.
Florida,
oh, yeah,
man.
sure. Alaska, Hawaii.
Houston,
Two
Texas.
Houstons.
Yeah, I think there are some
Three
other Lebanese around. We get some
Or
Romania,
Houston.
Houston. Bunch of Houston in a row. You guys could form your own
Yeah.
group. Orlando, Harold the Barrel. I used to own a comic book store in Orlando. I always say that every time someone says Orlando.
That's on the bingo card.
Ryan, you will need to create a bingo card that we can let out with the pre-show banters.
Well, yeah, good job. Good job, buddy.
If anyone
I think I'm
does,
gonna require a little elaboration on the bingo card thing.
Oh, it's all the catchphrases that we all use. If it's on the bingo card, you get to mark it off if we say it.
Ah, okay. Okay.
Um,
I didn't get my card, so.
like Jason's cat.
if I play any of these guitars, what's with the baseball? You know, all
Yeah.
those.
What's my cat's name?
We would definitely need Sad Plant on there, so.
Oh, this dog.
Aww.
Awesome. Thank you, everyone, for joining us on this workshop today. We're super excited to welcome Bill. And I don't really have anything else to say, Bill. I'm just going to have you take it away.
That sounds great. Hey, thank you, everybody. We appreciate you giving up your time. I've got 4 p.m. UTC and noon Eastern US. So we're going to get going. I'm really pleased to have you here today. I've been using Linux now for almost 30 years, just a little bit more. And it's been a love-hate relationship. I find that I can use it in a lot of different contexts, both work, play, outside projects, and so on. But it's a challenge. So for anybody on this call that's thinking, I'm here, but I don't really like Linux, and I really don't like command lines, I'm with you. It's a challenge to use them. They really don't want to make it easy for you to do your work. So today, this is your safe spot. This is where you get to try out how to use Linux without feeling self-conscious about, oh, hey, I'm going to screw up somebody's system, or I don't know what I'm doing, or somebody's going to look at me and say, hey, this is you don't know what you're doing. It doesn't matter. We're going to just try using Linux today, go through some of the basic commands, understand how Linux works, and you'll have a chance to try it yourself. My hope is by now that if you're on this call, you have a Linux system that you can reach. Now, whether you're typing on the console of a physical computer or a virtual machine or a cloud server, or you are SSH'd in to some machine somewhere, or you have some other way of getting to a command line, if you can do that, you're all set. If you can also run commands as root, that's going to be helpful for a number of these because you'll want to be able to do that. And if you have the ability to make outbound internet connections, to download new packages, that's also going to be helpful. There are a couple that are not included in the base install. It's also pretty flexible on whether you're using Ubuntu Linux or Debian or Fedora or basically anything. We've had a couple people say, can I use Kali? The answer is yes. Just get to a command prompt and we'll get going. If you've not already done so, please connect up to Wild West Hackin Fest's Discord server. A lot of the discussion that'll be going on today will be happening there. So if you go down in GoToWebinar's control panel, there in the chat section, there's a link to how to connect to WWHF's Discord server. Go ahead and connect up and head over to #live-chat. This is where we're going to have the primary discussion going on during the day. Also, if you want the slides that I'll be working off of, you can find those in #workshop-resources. That's a downloadable PDF. It is also, I think Deb said she would be putting up a link. I'm going to put one up. I haven't tried this myself, but somebody said that they were able to reach the slides. Let me see if I can find those. I can't find them here. So if somebody could put a link over in GoToWebinar's chat area, that would be great. All right. We're going to take breaks for 10 minutes at the top of every hour, and there won't be any technical content going on there. So you're welcome to take an actual break without wondering if people are going to be talking about the class while you're away from your headset. Grab a coffee, take a break, and then we'll see you at 10 minutes past the hour. If you have questions, you can use two places. The first, if it's just a quick question and you just need a straight answer, go to the questions window in GoToWebinar. There you can put in your question and one of our volunteers will answer it. We'll try to get as many questions answered as we can. If you have more general discussion, you'd like to have that happen with the other members who are taking part in today's webinar, go to #live-chat. And that's where we'll have more kind of interactive things going on with your other attendees. There's also, we already talked about questions. There we go. I want to put out a special thanks to BB, Brad, Deb, Jason, Justin, Keith, Naomi, Ryan, Sam, and Felda. We have all of them taking time out of their day to help with questions and problems and finding resources for you. I really want to thank every one of them for giving up so much of your day to make this happen. I appreciate it, guys. Why are we doing this? Well, as I said, as we started off, this is not an easy environment to work in. And I want to give you a chance to try these commands by yourself in a safe environment where you can understand what they do. And then when you later get access to a different Linux system, you can say, I've already done that. I've already seen that. Or Bill talked about that, but I can't remember what the command was. So this is where I hope you'll keep hold of this PDF and go back to it for reference if you need to. This is a little bit of an experiment. We've not done this format of lab before. So what we did was we put in 4 hours as an estimate for how long it will take. I can't tell whether we're going to get through these labs at rocket speed with few questions, or whether there are going to be quirks and hiccups and problems, and it's going to take longer than 4 hours. We'll try. We'll see how long it takes. And once we figured that out, then we can tune it next time and either add in more material or fix some things that aren't working and take a few out. We talked about this a little bit in the pre-show banter, but if you weren't here for that, I don't have a way to tell when you're done with your lab. So what we're going to ask is this. When you've done your lab and you're all finished, you're ready to go on to the next thing, I'd like you to go back to the GoToWebinar control panel. And somewhere around it, exactly where it depends on what control panel you're using and whether you're coming in through a web browser, but somewhere around it, there's going to be a hand. When you raise your hand virtually, I can see that over on my control panel, and I can get a sense of whether most people are done and we can move on to the next lab, or whether we have people who are still struggling with it and we should continue, go back over some pieces of it. I'd like to ask everybody to go to your GoToWebinar control panel, and if you haven't raised your hand already, go ahead and raise it. And this way, I can get a sense that you can get access to that and you can press that successfully. And I see a bunch that have already done that. Not everybody has, but the hope is that I can use that then when it comes time to figure out if we can move on to the next lab, and I can kind of respect your time and not rush through things if you're still struggling with them, but also not use up a lot of time if people are pretty much all done. So go ahead and lower your hands when you're ready. We'll go and we'll use that live when we get to the first couple of commands. All right. Don't worry too much if you don't have a network connection. If you can't get root privileges, or you're just on the console and can't SSH in. As long as you've got a Linux command line, we're on our way. Final note, you're going to know some of these. You've used them before. You've used some of these tools on Windows or Mac, or you've seen them on Linux already. That's great. Don't worry about it. If you get to a section that is just you're all done with it, guess what? Raise your hand. Say that you're ready to move on, and I'll use that information. So if everybody who's raised their hands can go and lower them, then I can use that information in a little bit. All right. Now, I've got on my screen the PDF that you have right now. And we'll go through some of these in detail, and we're going to I'm not going to read them out to you. But the first section is on the goals. What are we trying to do? You can read this at your leisure. The PDF should be up already. And let me just check something here. No, okay. Deb, when you get a chance, if you can put that link, the LinkedIn one, over in the GoToWebinar chat, everybody can have access to this doc at some point. It may be just a few minutes while she's getting that ready. What we'll do today, I'm going to show you the command. I'll talk a little bit about it. While I'm talking, you're welcome to try that command out and see if it works for you. If you've got some questions, if you have trouble running it, the command line options don't seem to be working. If you get an error message when you're trying to use it, go ahead and post either in the questions channel for GoToWebinar or over in live chat in the Wild West Hackin Fest Discord. We'll give you a hand, okay? Try them out. I discourage cutting and pasting for two reasons. One, you learn better when you type them yourself. You get to see what the command line options are. And the second one is just a functional problem. When you cut and paste from a PDF, occasionally the PDF decides that it's smarter about things like double dashes or quotes or single quotes or back quotes, and you get a mangled command. So I encourage you to try typing it in yourself, making sure that what you type matches what I did, and then you'll get a better sense of what's going on. Let's see, we talked about the hands. And by the way, if I move on to another section, you want to keep working on the previous one, no problem at all. Do whatever you want to work on. This is your time in your lab. You can do whatever you want. I'm not going to go over getting a Linux system, where to install it, or references to the cloud server setup. The instructions that we gave here were not intended to say you must use DigitalOcean for this service. That's not true at all. Anywhere you've got a Linux system, we're all set. But we did want to give you at least some step-by-step instructions on how to do this. And if you want to run this on a virtual machine or a physical box, that's fine. All right, let's get in. The first one is that we want to be able to connect up to the virtual machine that you set up before. I'm doing this lab on my Mac, and so I'm going to be SSHing to a cloud server at DigitalOcean. This could just as easily be a physical box to my left on the desk. It could be a virtual machine running inside VirtualBox, VMware, KVM, anything you want. But the idea is that I have a Linux command line to work with. Could you do this on a Mac? Well, actually, you can do some of these commands on a Mac as well because it is a little bit Unix-like. It's based on FreeBSD, but I would say you won't get the full experience out of that. So I'm going to SSH to the root account at my Linux box. And the first thing I'm going to do is notice that we've got a list of things that show the status of this system. I'm going to start by changing the root password. Oops. That's the first thing you want to do when you get access to a new system. We want to make sure that nobody else can get in on a default password that was assigned or a very simple password. So I've just changed it to something else, and I encourage you to do the same. This means that when you stop people from coming in and connecting to that account with brute force password guessing. So let's go back and take a look at this system information. This is Ubuntu Linux, and it happens to be Ubuntu version 20.04. The LTS means that it's long-term support, meaning that they make this available for, they give you updates and security updates for about, I think, 6 years. I'm not sure of the exact number. Give you a couple of links to more information about the system. And they also tell you how much disk space you have available, how much memory is being used, how many processes are running, and the IP addresses of this system. So I can connect up to this using any of these except for this middle one. Note that there are a couple of addresses that are internal to DigitalOcean. If an address starts with 10, 192.168, 127, or 172.16 through 172.31, those are called reserved addresses. Those are addresses that you can only reach inside that network. These other ones that start off with 167, for example, here, or this IPv6 address that starts off with 2604, you can SSH directly to those. So, for example, if I disconnect now, and I SSH to root at, there we go, that's it, Bill. Apparently I need to learn how to cut and paste. This IPv6 address, aha, I have a different default port. Ignore that. It'll say, are you sure this is the system you want to connect to? I'll say yes. and I type in my new password, and I'm in. I can SSH to either of those. All right. When you get into your system, now obviously this computer has internet access, this virtual machine has internet access because it's a cloud server. If it didn't have internet access, I couldn't have reached it in the first place. However, if you're on a virtual machine, it may not be the case that your computer has internet access. So I'm going to give you the simplest way to test that. If I do ping 8.8.8.8, that's one of Google's DNS servers. And one of the advantages of that particular machine is that it's easy to remember, and it's also accessible from anywhere. There may be a few countries that block outbound access for citizens, and so that statement is not universally true, but mostly true. So what I'm going to do is I'm going to say ping-C5, which says only send 5 pings, and don't try to look anything up, with -N. -N is a common command line parameter saying don't try to turn IP addresses into host names, please. So I'm going to run that now, and if I ping that, I get 5 lines of response saying I sent out a packet, I got a packet back. I sent out another packet, I got a packet back. Ping is a great way to tell whether you're live and connected to the internet. Down at the bottom, it'll give you a summary, how many were sent, how many came back, how, what's the latency, how many milliseconds did it take to send and receive the response, so you can tell if your network is slow or fast. But the point that matters is I have a live internet connection now. I can send packets back and forth to the internet. That's really helpful if you're on a virtual machine and you're trying to tell if your internet connection is working. Now, the other one to check, I'm just going to briefly show you this, but it's not something that you're going to need to work with right now. If you're having trouble doing lookups, if you think your DNS resolution isn't working and you can't look up host names, the other thing to try is ping-C5-N, -N, www.whitehouse.gov or google.com or amazon.com, whatever you want. And sure enough, not only did it ping, but it also chose the IPv6 address and pinged that. So now I know that IPv6 networking is working on the system as well. Either way works. That tells me that I'm able to look up host names, and that gets out 2 of the initial problems that you might run into when you've got a new system set up. All right, so I'm going to just take a look real quick and see. Looks like we've got some people with hands raised. If you're having trouble turning on networking, there is a block in this document. And thank you, by the way, from the people who posted that link up on LinkedIn. You can find the PDF that I'm working on right now. So if you don't have it already, go to GoToWebinar control panel, scroll down to the chat area, and there are 2 links here where you can find that PDF, download it to your system, and look at it in any PDF viewer. That way you can follow along with the commands that I've got rather than trying to squint through your screen and say, what is that particular one? That's a little small. If you're having trouble turning on networking, you may have to manually enable DHCP. It's not something you're likely to have to do. You almost certainly do not have to do this on a cloud server. It's possible you may need to on a virtual machine. But I include the instructions on how to handle that in Ubuntu 20.04. Unfortunately, there are a lot of different ways this works, so I can't give you a universal way to make this happen on all operating systems. We're just trying to give you the basic setup. Cactus, I don't know, actually that doesn't show up on every screen. Good. Cactus, the tool is called GKRelm, GKRELLM, and we will talk about that later. It's available for Linux, Mac, and Windows, and we'll talk about that a little further down. When you make network setting changes, you generally need to reboot the system. And the command for that I don't believe I've got that up on this screen, although I do have it later in the lab, is sudo reboot. No quotes around it. I'm not actually going to run this now, even though it doesn't take all that long to reboot a Linux system. Let's just not. This is if you've made network changes or something drastic and you want to make sure everything's all set, but it's not generally required. Linux systems don't need to be rebooted. Let me see here. If I look at the uptime command, this particular Linux system has been up for more than probably about 3.5 years. And there's no need to reboot it. Anyways. So once you've got that ready, I do want to make sure that you've got some basic updates in place. I wouldn't do this right now. I wanted to give you these commands early so that you could run them. But the command to update all packages, I'm going to type it out so you can see it. Is that sudo apt update ampersand, we'll cover all of these, sudo apt full-upgrade. What this does is it says, I'm going to use the apt advanced packaging tool to upgrade, to install new software. But the first thing we have to do is make sure that we have an up-to-date list of what's available for this system. Apt update pulls down the up-to-date list of what's available for this system. The other one to note is this part called sudo. It's short for a super user do, meaning I want to run something as the root account. If you're used to Windows, it's the administrator account. But in Linux, it's called root. It's the account that has no limits on what it can do. The root account can do anything. So when I'm messing with the internals of the system, like upgrading software and packages and making core changes to networking things and listening to raw packets on a network interface or viewing everybody's files, I generally want to do that as the root account. So this block right here says, I want to run as root the piece of the operating system that works with packages, and I want to make sure we have an up-to-date list of what's available. If that's successful, I want to go on and do something else. And the way to check, was that successful, is called ampersand. This says, if this first part worked correctly, I want to go on to the next part. If it didn't work correctly, don't try to do this other part over here. Let's just error out and we'll figure out what went wrong. This means that you don't try to go through and do the second half of the command until the first half worked correctly. So the second part is similar. I want to run as root. I want to use the package management tool apt, and I want to do a full upgrade. You may see this as upgrade. They're basically the same. Full upgrade does a couple of extra things, but they're equivalent. So either of those are fine. I'm not going to do this right now. And the reason is that this can take a few minutes. I don't want to take time away. But you can do this on your own system. It could take a few minutes. In fact, if you've got a lot of packages that haven't been installed yet, this could easily take 10 or 15. So I'm just kind of suggesting during the class is not a great time to do it. Wait till you're done at the end of the day, and then you can upgrade these packages. You can, however, do the first part. And I say that because you do want to have an up-to-date list of what's available, because in just a moment, we're going to install some additional stuff. So let's do that right now. It'll go out and grab the up-to-date lists of what's available. It'll think, crunch, chew through things, and then it'll say, hey, you could go and do some upgrades later. We will do that later, but not right now. The next thing we're going to do is look at the list of packages that we may be working with today. And this has shrunk a little bit since the original email went out on Saturday. A couple of reasons. One is a few packages have been removed in Ubuntu 20.04. There are some that we just aren't going to use. I thought we were going to use them when we were originally doing these labs, and for different reasons, we're just not. So this list is going to be a little shorter than what went out on Saturday. My apologies. But this is effectively what we're going to work with. Note, we're still using sudo. We still have to do this as root because we're messing with the installed software on the system. apt is the package management tool, and we're going to install software. I'm adding -y to the command line saying, I know you're about to ask me, are you sure you want to do this? And I'm just going to tell you right off the bat, go ahead and do it, please. Don't ask me, just do it. So I'm going to run this command now, and we'll go over all of these tools today. Don't worry too much about them. Some may already be installed. That's great. Some may not. We'll put them in. And if you're working with a different Linux distribution, please understand that some of these package names may be different. So if you're using Kali Linux or Debian or Red Hat or CentOS or any of the others, and you say, well, this is kind of interesting, but I can't find this package, what's the equivalent? You can either do a Google search for your Linux distribution name and the package, or you can ask over in #live-chat and see if somebody else can give you a pointer of what package name to use. In short, these should all be pretty standard ones, and I think you'll be able to get most of them. I'm going to run that now, and it's going to fly through. Great. I'm basically just going to hit enter on all of these. Should super users be able to capture should non-super users be able to capture packets? I'm going to leave that at no. If you've got a low security system, it's one that you work with yourself, you could turn this on. But remember, we're going to use sudo to do root level things. It's generally not needed. If you're being asked about DD client or DD update or bro-aux or bro-ctl, just leave those off the command. You may have the original list that included some that we're just not going to use today. Also, you occasionally get these prompts saying, do you want to install a new version or keep the local version? In most cases, you keep the local version because you've made some changes. You want to keep those changes rather than installing the new configuration file that's coming down with a new package. This is a really tricky part of sending out packages and letting people make their own customizations. What happens if the local users made a customization and the new version of the software is different? The short version is generally keep the local version currently installed, but you can also start comparing the two and finding how to merge the changes. We'll skip that today. A lot of things that happen in the background are things like merging in manual pages so that they're easily found. Packages are pretty smart. They're pretty good about telling the operating system, oh, by the way, after I'm done, you need to do these other things to go and make sure that I'm installed correctly. Pretty soon, you're back to a command prompt. All right. If you have a Linux system that has a graphical desktop on it and you just happen to be typing in a terminal or on the console, that's great. There are two more packages you can consider installing. I won't do them here because I don't have a graphical desktop already set up, but I will type out the command so that you can see it in slightly larger font. Both of those are graphical applications. Just like Windows, just like Mac OS, you have graphical tools with drop-down menus and file and edit and help menus in the top right and all the rest. We won't be using these all that much today. If we need them, I'll go and install them later. One quirk is, if you haven't installed any graphical tools yet, you'll have a lot of extra packages to install. because things like font management and window management and what's your windowing system, there are a lot of things in the background that make graphical tools work. So these would be long installed. I'm not going to run these right now, but you're absolutely welcome to if you have a graphical desktop. And I'll even show you how to run graphical tools without a desktop a little bit later in the talk. Final setup task is to make an account where you can log in without being root all the time. So here's how you do that. The commands are listed over in your lab workbook, but I'll type them out here. I'm going to use the user add command. If you're on an RPM-based system, Fedora, CentOS, Whitebox, SUSE, Red Hat Enterprise Linux, you'll probably use add user and the name of the account with nothing else on the command line other than sudo, of course. On the Debian and Ubuntu sides, you generally use user add. And so here's what I'm going to set up. I'm going to make an account called lab user. As I said, you can use either user add on the Debian side or add user on the Red Hat side. You have to do this as sudo because you're adding privileges to the system, and we want to make sure that you have the rights to do this. M says make the home directory, and -- group says add this to the sudo group. What this does is it immediately grants that user the ability to run commands as sudo, so that I can switch out of always being logged in as root and instead switch to a non-root account. So let's run that right now. Oh, I ran it yesterday. Okay, cool. That's half the fun of setting up a cloud server. You can never remember what you've reverted. So I should be able to do password lab user, assign a password to it. Oh, apologies. I'm going to do this the right way. Here we go. I want to put sudo in front of that to say I can run this as root. I'm going to get back to that in just a second. So if you've got questions about that, hold on for just a moment. I pick a new password. We put that in. And now, if I log out as root and SSH to lab user at, and I'm putting in Linux lab because I've already set up an SSH configuration for this, but you can put in the raw IP address. That works just fine too. When I connect up, of course, I've already set it up so that it will connect up directly. Yep, okay. So I set up key access already for this, and that's why it logged in immediately. Now, if I type sudo space who am I, it's going to ask me for my password. I type that in. This is my password, not the root password. But it switched to the root account to run the command, who am I? If I just run who am I without putting sudo in front of it, I get my own account. So with the sudo command, I get to switch to a different account, root in almost all cases, to run something that needs to be run as root. Make sense? Some of you may have been asking, well, wait, Bill, you were logged in as root, and you're putting sudo in front of all these commands. It's a good habit. First of all, it's a good habit to not use the root account, but we hadn't set up an account yet for testing like lab user. But it's a good habit to put sudo in front of commands that need it. If you happen to already be root, that's okay. Nothing breaks. But it means that you don't have to think, geez, am I root or not? Just put sudo in front of it if you think it's going to need it, and things generally work. All right, so now I would like to ask you to raise your hands if you are all set with this section. If you want to take a few more minutes and try some of these commands out, if you started running sudo apt full upgrade and things are taking a little bit longer, you can hold off raising your hand. But I want to make sure that people have had a chance to try these commands, to set up the lab user account, to feel ready to move on. So I'm going to hold off for at least a minute, and we'll see how many hands get raised. And when it looks like things are pretty much done, we'll move on. Okay? I see someone who tried to do an apt install and could not get locked. What that means is that at any moment, only one program can be playing with a list of installed packages. If you get that message, it means that there's another program in the background trying to install or update packages. Linux systems usually are smart enough to hold off maybe 10 or 15 minutes after boot time before checking to see if there are updates automatically, and in many cases installing them automatically. But while they're doing that, if you happen to come along at that wrong moment and say, I want to install this other packages, it will come back and say, hey, some other program's working with the list of installed packages. I can't really screw with that at the moment. Don't worry about it. It's not an error. It's not a problem. It just means somebody else is installing stuff in the background. And it's almost certainly an automated process that just happened to run a few minutes after you started the system or once every 24 hours. Are there any other questions that are coming up in either live chat or in GoToWebinar that I should cover, volunteers?
I got one question for you.
Yeah.
How do you log out from the command shell and log in as a lab user? Sure.
Oh, perfect. Great. So let me go back to where I was. I was logged in as root before. So,
whoops.
So here I am. I'm logged in as root. Now remember, a little while ago, I made up a new account called lab user. And what I want to do is disconnect from this and then reconnect as the other account. I'll show you another way in just a minute, but let me show you the basic one. The first way to do that is to hit Control D, which says I have no more input for you. But the more explicit way is to type exit. And that closes down the command shell that I'm looking at right now and returns me back to my laptop. So now I'm typing on my laptop instead of my Linux lab server. Once I've done that, then I can change the account name from root to lab user. And I connect right out to that remote system as lab user. It will usually ask you for your password. I had this already set up to accept SSH keys. We'll see how to do that in just a minute. It's hard to kind of organize this in a way that builds up in a linear fashion. I have to kind of reference things that we'll talk about a little later. The other way, by the way, is to say I want to switch to a different account with su-root or su-lab user or su-bill s or whatever the account name is. If I do that, I'll be asked for that user's password, and I can type that in, and I directly go to that account. And now I'm logged in as that user. So you can actually switch back and forth all day long with nothing more than su- commands like these. And because I was already root, it doesn't even ask me for my password. It says, well, you had the privilege to do anything you wanted with that account anyways. I'm just going to let you go. The dash, by the way, says when you switch to the other account, use that account's environment. All right, so just double checking on the hands raised. It looks like we've got quite a few who are already finished with the lab. If you've got questions, if things didn't make sense, if you're still running into problems, please check in on workshop prep questions. Sorry, on live chat, my apologies. We're on using that channel now. Or ask questions over in the questions window of GoToMeeting. All right? In a lot of these sections, I'm going to have references. This one was how to get to the DigitalOcean console. Remember, there is no physical console on a virtual machine. So if you want to get to a console on a cloud server, you're essentially doing it through a web browser. And DigitalOcean has very explicit instructions on how to do that on their environment. So do the other cloud providers. By the way, we're not getting any kickback from DigitalOcean or any other program or service we recommend during this talk. I'm only recommending DigitalOcean because it's very straightforward and easy to get set up. I did one talk for a Linux users group where I did the entire setup of a virtual machine using nothing but my nose. It's a cute little trick, but it really is that simple. All right, so let's go and take a look at command line essentials. What do you need to know when you first logged into a system and you want to be able to work with that system? Well, first of all, what's running on it? I'm going to start off right off with the command ps space axf, and I'm going to send the output of that command into a well, first of all, let me run this just as is. So sudo space ps axf. It says, I want to make sure you have the privilege to do this, so type in your password. I do that, and you'll be asked the same thing. And what you get is a list of running programs. I'm going to run it again. And you'll notice that these programs are indented. I see the listening SSH process. This is where I logged in as lab user. This is where I became root. This is where I became lab user again. This is where I ran sudo psaxf, and this is where I ran psaxf. You notice how all of these are indented all the way down? That's called a forest view. That's the F command line parameter in psaxf. It's not available on macOS. It certainly is on Linux. And the advantage there is you get to see that one process was started underneath another. But you also notice that this is kind of hard to read because there's lines scrolled up off the screen. While I can certainly scroll back a little bit. The better way to do this, I'm going to back out here just a little bit. Hold on. Is to feed the output. Here we go. Sudo psaxf pipe less -s. If you've used the more command on Windows, it's the same thing. You're taking the output from one command, you're feeding it into something that will display it and let you scroll up and scroll down. It'll show you a screen at a time, but this is a little bit stronger than that. More will only let you see a screen, go on to the next screen, go on to the next screen, and then when you're finished, you're dumped back out to the command prompt. Less will hold all of the output. I can scroll up, I can scroll down, I can scroll up, I can scroll down, I can scroll right, I can scroll left. That's what that -s command parameter does, by the way, is it says, don't wrap the lines around, even if I've got a really small window. Hold them, and if you notice over here, there's some arrows on the far right of this display, meaning there's more to the right. So I'm going to hit the right arrow, and it will let me see those longer lines, and I can keep going as far as I need to see the whole command. But just like with the more command, I can scroll down, I can see more of it. The other nice thing is less, if I use escape less than, which is the above the comma on my particular keyboard, I go back to the top. If I hit escape greater than, I go all the way down to the bottom. So let me go back up to the top with escape less than, and then I'm going to show you a trick. With less, I can type, I can hit slash, and I can search for something in the text that's being displayed. So I know there's a process called Nginx running on this system already because I installed it last night. I'm going to search for Nginx in the output. And sure enough, it will scroll me down to the, in this case, 2 commands that have Nginx in them. It highlights that text, and then I can see that it's running. This is helpful if you need to find something in a huge mass of stuff and you know what you're looking for, but it just takes too long to find. All right. So let's say I want to do something different. I only care about lines with Nginx in them. So I'm going to type sudo psaxf pipe, and in this case, I'm going to say only show me lines that have Nginx. grep is the tool that you use that looks at what's coming in from the previous command, which is psaxf, and says only give me lines with Nginx in them. And in that case, I get 3 lines. I have the parent process that's listening on port 80. I have a child process that's ready to answer the first request that comes in. And I also have the grep command that I used to look for Nginx. Technically, this has Nginx in its command line, so it's kind of an odd quirk. If you don't like that, you can do sudo psaxf pipe grep Nginx pipe grep-v grep. So I say, give me all the lines that have Nginx in them, and then throw away any lines that have the word grep in them. It's a little cheesy, but it gets us back to the 2 that we truly care about. So you can look for running processes this way as long as you know part of the command line that they use or the process name that they use. You can look through the list of running processes that way. We've talked about sudo. So if I have a command that tells me, hey, I can't do that. Let me give you an example. I want to, let's say, listen for raw packets on an interface. I'm going to just real quick show you that this is using ETH0 as its first live Ethernet interface. And I'll show you TCP dump a little bit later, but let me just use this as an example of when you have to use sudo. That's just a basic command line that says listen for packets on ETH0 and show them to me one at a time. And it will say I can't. And the problem is that if I'm running them as myself, which in this case is lab user can't listen on network interfaces. But if I do sudo tcp dump -i eth0-qtnp, I've screwed up my terminal, but we'll fix that in just a minute. If I do sudo, then it will very happily show me the packets running back and forth across that wire at high speed. If I want to save the output of a command to a file and be able to see it later, no problem. I just run the command that I want to do. So let's say, here we go. I'm going to use the lsof. Let's do that ps command that we've done in the past because we've already seen that one. So sudo psaxf, and I'm going to redirect the output to a file, and I'm going to call that ps_axf.text. The output gets saved. I'll take a directory listing with ls-al, and you notice we have a file in here called ps_axf.text. Now I can go back and look at that, use grep on it, use other types of searching and sorting, but the short version is less ps_axf.text, and I have this as a text file instead of the output of a running command at the moment. That file won't change even if the list of running processes does. So use psaxf if you want to see what's running right now, but if you want to keep a snapshot and do some work with it for the next 20 minutes or so, you can save the output to a file and work with it by hand. All right. If I want to save any error messages, I'll show you the syntax here. It's just slightly different from the previous command. It's sudo psaxf greater than ps_axf.text 2 greater than &1. Ugh, ugly. Just remember it. It says take the standard error output which is where any errors created by that command would go, and redirect them, that's the greater than, to the place where the output is going. Now remember, we redirected the output into a file. So as long as you do it in this order, you redirect the output to a file, and then you type space 2 greater than ampersand 1, both the output and any error messages will get saved into that file. PS doesn't normally give us error messages, so I need to come up with a better example than that. But that's how you save the error message. Down here, there are multiple ways where you can get more help on a command. I'm just going to be touching the surface of these. There's no way I'm going to cover all of the different options that you could have. So when you've got a command and you want to know more about it, how to run it, what options are available, oh, I forgot what that option was, you can use these all day long. Let me give you a couple of examples. Man PS. This gives you a manual, an online manual for that program, and it will list off the different options that you have, how it works. So for example, there's some examples right down here, and there are tons. I can't go through all of these. And even if you scroll all the way down to the end, it can also say, see also, and there are these other programs that are in the same category as this. All right. Man is not the only one. There's a separate type of documentation that never caught on quite as much called info PS. It's much the same as the man pages, and in fact, it may be identical content in some cases. I'm going to cue to quit out of either of these. They're actually sending their output into less. The other thing is just to try running it with a -H or --help option. PS-H. Now, there is some, they actually used -H for something. That didn't work, so let me just try PS-help. Well, that didn't work. Yeah, actually kind of did. For additional help text. So PS-help space simple.
Hey, Bill.
Yeah.
We've had a couple of requests. If you could make your font in your terminal bigger. I don't know if you saw
it. Absolutely. This is really hard to see. So let me go and bump that up. So is that going? So if you had trouble seeing it before, and you're still having trouble seeing it, can you send in an additional request, and we will bump it up as large as you want? Okay. I'm also going to show you briefly how to, I'll tell you what, let's see here. We're going to get down to this in, sorry for scrolling up and down so quickly. Nope, we're going to do it right here. Here we go, perfect. So one of the common things that you need to do when you're sitting at your laptop and you've made a connection into some remote computer, I may want to be able to move files back and forth. Look, it's great that we've got a Linux system, but I've got all my tools on my laptop. So I want to be able to pull files from the Linux system back to my laptop, and I may have a file that I need to install on the Linux system, and I need to be able to push it from my laptop over to the Linux system. The nice part is that there are two commands to do that. There's one command to do that, actually. And we can use it to push files either direction. So let me bump up the font size a little bit here. All right, so if we go to /temp. /temp is a nice place to put files briefly because everybody can write to that directory. There's no problems with getting content in there. There's a whole bunch of garbage in there right now, but that's okay. Don't worry about it. So I'm going to push a file. I'm going to pull a file from the Linux system back towards me. All right. SCP Linux-lab :/etc/services to /temp. Let me read that off. SCP is secure copy. What you send is encrypted in both directions. I'm going to pull a file from the Linux lab system, and the colon there says what's to the left is the name of the computer where I want to get this file. The file I want to get is called Etsy Services. It's just a standard part of what's installed on a Linux computer. It's not a major configuration file. And I'm going to pull it back to my laptop, and I'm going to put it in the temp directory. So let's run that. And it's going to ask me for my password. I put that in. And now if I go to the /temp directory on my laptop, and if I could type, there's now a file called services. Let me look at that with less space, services. And here we go. This is the file that got pulled back from my Linux computer. All right. I'm going to show you the other direction real briefly. So I'm going to put the words hi there, and I'm going to put them into a file called test77. And remember, this is on my laptop. You see how the prompt says it's WLS Mac Pro? This is my Mac. So if I cat the file, test77, there's a single line with the words hi there in it. I want to push that over to my Linux system. I'm going to put in the name of the file that I want to send. I want to send it to Linux-lab, and you can use the IP address of your lab system if you want. And I'm going to put it over in the temp directory on the remote computer so that we can see it. So you notice that Linux-lab : is on the right-hand side. And the colon is what signals to SCP that we're talking about a remote computer. So I'm taking a local file, test77, and I'm pushing to the Linux lab system, and I want it to end up in /temp. Going to ask me for my password again. I put in my password. I type in my password better. You gotta love it. Here we go. Let's do it with the lab user account. And sure enough, if I go to /temp, I should see test77 show up in the list. And if I look at that, up comes the content. So this is a very basic tool, but it means that you can move files over to your Linux system and pull them back. SCP is the tool that makes that happen, but it's based on SSH. So the fact that you're able to SSH into the system is all you need in order to be able to use SCP to move files back and forth. Okay, we just out of reference, I think I saw somebody ask, how is Bill SSHing to those machines without typing the IP address of the system? And the answer is in a webcast. And it's in a blog post that we did. I'm going to show it to you a little further down. But if you scroll down to the SSH page, the last URL on that page is how I did that. And you can do this yourself. I encourage you to do this yourself because I'm not about to go and remember IP addresses forever. My brain is just not that good. So another question was, can we use this SCP trick to bring files on and off the system? The answer is yes. Could somebody use this to exfiltrate data out of a network? Yes. And in fact, what you would see is a whole bunch of SSH traffic going back and forth while files are being transferred on or off the system. And because it's encrypted, you can't tell what's going on inside. There's some good guesses that you can make based on the timing of the packets and the size of the packets. But SSH is a double-edged sword. It's how we keep our communications safe, but it's also impossible to look inside without some real tricks. And that means that somebody can move files on or off the system. All right. We've already talked about the less command here. We've used the less command to say, hey, let me take a look at a file. So if I go back to that temp directory and I take a look at test 77, I can look at it with the less command. I can scroll up and down. I can search for example, TH. And if I search for TH, sure enough, it's in there. Happens to be a single line file, so it doesn't teach all that much.
Hey, Bill, quick question.
Yes.
Should they have SSHD installed for this?
In order to be able to connect up to a system, you have to have the SSH daemon running on that system. Let me show you that. If I do PSAXF and I feed that into less-s, the same way we did it before, and now I'm going to search down for SSH. The daemon is this one right here, SSHD. And this one right here as well. This one is listening on port 22 and waiting for people to come in. And there are a total of 3 different connections coming into this system simultaneously. But you have to have the SSH daemon running in order to connect to a computer. I do not have to have the SSH daemon running to be able to type SSH or SCP or anything else that depends on those to connect to another system. The SSH daemon is only needed if you want to be able to accept incoming connection. Does that make sense? I'd love to be able to look at your face and see yes or no. But if it doesn't, write in and we'll go and clarify. We've got plenty of time to do that. All righty. So we've already looked at the less command, and I've shown you how you can search down with /. So we search down in this case for SSHD. If I hit / and enter again, it'll look for the next line that has SSH in it. And if I hit / and enter again, it'll look for the next line. / and enter again, look for the next line, and so on. And so I can quickly move down from line to line and see all of the things that are coming in. T. Manster made the comment, it's not part of a standard desktop build. And that may be true. You may have to install it manually. So just like we've installed packages a little further up on the screen, you may have to install OpenSSH-server. So that's one of the reasons why I encourage people to use the server build for things like this, but you can absolutely do the desktop build. On a desktop, you're more likely to be SSHing out to other systems, but you can absolutely accept connections coming in as well. All right. Oh my, here we go. One more before we leave this section, and that is editing files. There's a holy war. If you ask people what their favorite editor is, you can start an argument that'll last, 3/4 of an hour and go through 4 or 5 beers at a bar. Though most people don't go to bars to complain about this. The 2 common ones that people like are Vim, V-I-M, and Emacs, and they are both confusing if you just started using Linux. I'm going to encourage you to use a different one. So in this case, we have a file called test77, and I need to edit that file. No problem. The editor I'm going to suggest you use is called Nano. I believe it's going to be installed on at least Debian and Ubuntu systems. I'm not certain about Red Hat and CentOS, but it certainly is available on them. Just like any other editor, I give the name of the file that I want to edit on the command line, and I hit enter. Immediately, I'm dropped into edit mode. This works just like you'd expect, just like Notepad on Windows. I can go up and down, the arrow keys all work. And then if I want to add a new line, it shows me that I've modified this. Hold on a second. I'm getting a beep here. There we go. It shows that I've modified it, so I need to save my changes. If I hit Control X, you see how there's a caret X here? This is the hints section that reminds me of the basic keystrokes that I need to use Nano. If I type Control X right now, it'll say, ooh, hold on, you changed that. Did you want to save that back to disk? And I can say yes. I'm going to hit Control C for the moment, and let's do it the right way. The right way is to write this out first before I exit. And to write it out, that's caret O or Control O on your keyboard. Do you want to change the file name? Nope. So I just hit Enter. Aha! Mission denied. I wasn't allowed to save that. So I'm going to write it out to test77.temp. He'll say, you sure you want to use a different name? I'll say yes, because I forgot to check permissions. And I'm going to exit. And, interesting. The problem was that test77 was owned by a different user. And so Nano was warning me, I'm not sure I can do that. In fact, because I'm logged in as root at the moment, I can. But it was just warning me. So Nano is a much easier editor to use than Vim or Emacs. You can absolutely learn those. You can definitely find resources on how to get going with them. And it's good to know the skills, but Nano is an easier way to get going. All righty. So that's the end of the command line essentials. That's just kind of getting you through working with Linux command line and getting logged in. Again, if you have questions, put them up in live chat. Ask what you have, and we'll try to get as many answers as we can. I'm going to move down to the next section called System Hardware and Networking. It helps if you can understand what you're looking at. So when it comes time to install a new package and the package says I need to have 16 gig of RAM to operate, do I have 16 gig of RAM? How do I know? Let's start off with that one because that's a very easy question to answer. This will work on pretty much any system you have. You may need to install the LSHW package. LSHW stands for List Hardware. To use it, sudo lshw -short. Let's start off with that one because this has got a lot of detail. Let's take the simpler version. Sudo lshw -short, and I'm going to feed that into less-s. Remember, the -s says don't wrap around if the lines get long. It takes just a moment. It may take 3 or 4 or 5 seconds in worst case because it has to go through and look at the system and see what's on there. And the beauty of this is that it does a really good job of summarizing what's on your system. Virtual machine, cloud server, physical box, doesn't matter. It does a really good job. So if I need to know how much memory I have, in this case, I have 2 gigabytes of system memory. And so if I'm installing a package that needs 16, I'm out of luck. We need to go get some more RAM. If I want to know what type of drive I've got on this system, you want to look down for storage or volumes. And in this case, I have a 53 gigabyte virtual block device called VDA. 49 of that is available as my root file system. And then there are a couple of other partitions that do a couple of other things. This is a really handy way to get a sense of what's on the system. Now, if you look over at the PDF that you downloaded, there are more commands underneath, and I encourage you to give these a try. They're just a quick modification of the form that I just showed. So, for example, if I just want to see memory, I'm going to add -C space memory to that command. Let me quit out of where I'm looking now. And I'm going to add -C space memory. And it will still do a bunch of lookups, but then it's only going to show me the class of device called memory. In this case, I can quickly find out that I've got 2 gigabytes of memory. Try out the other ones as well. Take a look at what kind of output you get. And I'm just going to briefly take off the dash short and show you the long form. And there is a lot in here. This is listed in a hierarchical display. It shows you the individual items and their sub devices and their sub devices and so on. You can see the individual processor. In this case, we have only one processor on this machine because I'm cheap and I wanted to be able to do this lab for less than a US dime. And all kinds of detail, down to the individual banks of memory. Now, it doesn't make much sense on a cloud server. There's really only one bank, but you may find yourself in a situation of saying, can I add RAM to this computer? And now you need to know what chips are in each slot in order to know if you have any free slots to put new RAM in. There's a lot down here. We won't go through all of these. If you have specific questions, we can certainly go over them later. So try out those other ones that I've got listed in there, the processor, storage, disk, volume, network, and display, and get a sense of what's on your system. I think it's kind of interesting sometimes to see what devices show up in a virtual machine, even though there's no physical hardware associated with a virtual machine. I'm going to switch down to looking at the block devices. Block devices are drives. Hard drives, SSDs, thumb drives, SD cards or micro SD cards. They're drives where I have this long list of 4,096 byte sector blocks that all add up to a 64 gigabyte, 128 gigabyte, 1 terabyte device. So on this system, I'm going to do lsblk, list block, and I want to see the file system attachment. Oops, that's going to wrap around the screen. That's not going to look very good. So I'll do less-s here again. And I'm going to make this a little wider so we can see as much as we can. There we go. So I'm going to skip these ones up top for the moment and come down here to Virtual Drive A, the first one on the system. And there are 3 partitions on here, Virtual Drive A1, 14, and 15. A1 is the root file system, top level drive of the computer. You can think of it as C:\/ if you're from the Windows world. It's where most of your stuff goes. There are ways to break up this hard drive into smaller components for isolation. Let's leave that for the moment because that's really getting down into system optimization. Many cases, with the exception of Red Hat Enterprise, you get just basically one drive and all your stuff goes in it. In this case, it's a 44 gigabyte drive and it's only 9% used. So I've got another, so 1/10, 4.5, so about 39.5 gigabytes available. These others, there are uses for them, but we're not using them right now. Up here at the top, these are a little bit, this is an oddity for Ubuntu, and this is how they install some packages as snap. A snap is essentially like a zip file that never gets opened up. You download a snap as a running application, and then when you need to access it, you kind of access it inside the zip file. It's neither here nor there. It's just a different way of installing software. So in addition to seeing those block devices, I'd like to know how much space is free, and the equivalent command for that is df-h. df is disk free. And H is human readable, please, because I don't feel like looking at long strings of digits and adding commas in my brain. And this is beautiful because I can see, here's my root file system, the fourth line down. Just like we saw before, it's on VDA1. We've used 4.5 gigabytes of it, and we have 44 of the original 49 available. DF is a great way to tell whether you're running out of disk space. We'll show a little bit more of that in a little bit. Okay, so that's the major hardware, and that's also the storage that we've looked at. The third category are the network interfaces. And there are a few commands for looking at these. Let's take a look at them individually. The older command is called ifconfig, and while it's technically deprecated, it's been replaced by a different one we'll see in a minute. I would like to show it to you just briefly because it's available everywhere. And once you've learned what it is, it really is actually very good for being able to tell what's on your system for network interfaces. In this case, I have two of them. On every Linux system, you have an interface called LO, called the loopback interface. Any packets that you send to the loopback interface come immediately back to me. So if I ping the loopback interface, it doesn't leave this box or virtual machine or cloud server. It comes right back at me. And so I can always have IP address 127.0.0.1 as this computer. By sending packets to that IP address, they come immediately back to me. So this is why we'll do a couple of the labs coming up, and we will look at 127.0.0.1. It means that you're not ever running the risk of sending packets off to somebody else's computer. We also have a real interface, or in this case, virtual, because nothing's truly physical on a cloud server. And this one is called ETH0. Now, the functional lines are right here. These are the network IP addresses. Here's the IPv4 address, and here's the IPv6 address for this computer. You notice there's another one over here called that starts with FE80. It's technically an IPv6 address. But the catch is that's a local address. It will work with other machines on the wire, but you can't use that to communicate outbound. If you've got only FE80 IP addresses, then you don't have IPv6 available. Because I've got one that starts with 2604, I do have live IPv6 networking, and the clue for that is the word global over on the far right. That says this is globally accessible. I can use this to reach other IPv6 systems, and other systems can use this address to reach me. So as you're sitting on this webcast right now, I have no doubt that 12 of you have tried to log in to root at either of those IP addresses. I can't stop you from doing it, but I will remind you that I didn't give you permission to do that. So I would encourage you not to. You may, that's not. I'm briefly mentioned that there's a MAC address for this as well. That's a unique address assigned to this interface. And this 12-character address is broken up into two parts. The first is the manufacturer, and the second is the unique address underneath that manufacturer. So you can actually use this in some cases to figure out what type of hardware is in there. I'm guessing that if you look this up in a what's called an organizational unit identifier, or OUI file on the internet, you'll probably find it's something like the clouds, the virtualization software that's being used at DigitalOcean, or it might even say DigitalOcean. I don't know. You can also see how many packets are sent and received here. In this case, I've moved about 700 megabytes out, received 700 megabytes and sent 600 megabytes. So that's the Cook's tour of ifconfig. There's one other command line you should be aware of, and that is -A. So if I run ifconfig -A, it says show me all of them. And in this case, all of them, we actually have seen all of them. There was just ETH0 and LO. If you have an interface that exists but has not been configured, if it's not up, it won't show up in the original ifconfig. It will show up in ifconfig -A. So if you think you've got an interface that should be there but you can't find it, add -A to get the full list. The replacement for ifconfig is called IP. And this one is a much more complete, I think it's IP list or IP adder. IP adder. There we go. Sorry, I shouldn't type that fast when I'm doing a lab. My apologies. The correct form of that is IP space ADDR. There are other things that you can look up with the IP tool, but I'm going to use that one for the moment to show you the addresses. And if you look, we have the same loopback interface. It's still got the IP address 127.0.0.1. And we also have ETH0 showing in the output. And here we have the IPv4 address. There is a second IPv4 address attached to this. That's the internal address for local communication. Here's the public IPv6 address that you can tell because it has the word global next to it. And here's the private IPv6 address that you can only reach if you happen to be on the same network as this virtual machine. So you'd have to have another cloud server inside DigitalOcean to be able to use this last address. Same thing as ifconfig, it's formatted differently. This is the way that we'll use kind of in the long term. I wanted to at least show you this command, but seeing it in both forms mean that you can use either one. So the other one is not installed by default. The old way to see the routing table was route space -n. Oh, it is installed. Here we go. Great. Depending on what version of Linux you have, it may say, I'm sorry, I don't have that command. But the routing table says, I have a way to reach the internet, 0.0.0.0/0.0.0.0, and the machine I go through to get to the internet is my router at DigitalOcean, and it's going out through the ETH0 interface because that's the only one we have. The other way to see the routing table is IP space route. And I think that's short enough that we can show it. Yeah, there we go. Same kind of thing, they just get formatted a little differently. So use whichever tool you want. This one might actually be a little bit easier to do scripting from, but whichever one gets you the information you need is great with me. IP will actually do a lot more. We won't get too deep into that, but it is helpful to know that you have a live connection to the internet. It is helpful to know that you have IPv6 connectivity or not. And we saw above how to use ping 8.8.8.8 to verify that you really do have internet access before you move on.
Hey, Bill.
Yes, please.
Before we move on, we had a question. Wasn't sure if you wanted to cover it. They were
Anytime.
asking if you could step back and explain the differences between the file system types displayed in the output of the df-h command.
Shall do. Perfect. And that's a great time to do it. So df, as we said, was the disk-free command with a human-readable form. And I'm going to feed that into less so that I can see it more easily. Most of what you deal with on a Linux system is the ext4 file system or XFS, or there are a few others. Linux systems have a few that are just normal ways of storing files on disk. If you think about a thumb drive, if you put it into a system and it says, hi, a new FAT file system has been found, or I need to erase this, can I put FAT on here? That is the file system that you normally use for thumb drives and portable drives. Linux uses something called ext4. We don't actually see this up here. It says the file system is VDA1. It's being a little bit short. I'll show you how to see that in a minute. Now, there are a few more, and most of these are what are called virtual file systems. They kind of, sort of don't truly exist. Let me give you an example. So I'm going to go back and switch to where we get more detail on that with the mount command. Mount says what underlying drive is being used, what file system's on there, and where does it show up. Let's take a look. And there's a whole bunch of garbage on here, but let me show you why I'm doing this. Here's our Here's our root file system on line 6. The underlying storage is the first partition on VDA, and the file system type is ext4. This is the default one that's used on Linux. There are a couple of others, but you'll mostly see ext4. It's a read-write file system, meaning I can make changes to it. If you were to stick in a CD-ROM or a non-rewritable DVD, it would show up as RO, read-only. Ignore the rest of the command line parameters. They're not really relevant to us. Pretty much, so proc is created by the kernel. sysfs is created by the kernel, and I'll show you proc a little bit later. Sys is similar, but it's the same idea. They don't exist. There is no underlying storage for those. The kernel publishes some of its settings in /proc and /sys. But they're not actually stored on any drive anywhere. A lot of these are the same way. tempfs is a RAM disk, and it's mostly what you'll see. It's very common to put the temp directory on a RAM disk. A RAM disk allows you to store files blazingly fast and retrieve the contents blazingly fast, but it uses up some of your memory in the process. The rest, I think I'm going to punt on, and not because they're not interesting, but because you really get down into very esoteric topics. C groups are process groups. It is far more detailed than I think is worthwhile for a starter class like this. And there's so many of these. The debug file system, the trace file system. Fuse is the user space ability to mount things that aren't really there. So I can, as a user, mount a remote drive and make it show up like it's local. Fuse control is the way I talk to the kernel to make those happen. There's a lot in here that I think we should probably skip. If you have specific questions, catch me on Discord after the class is over, and I'm happy to go over any of these. All right. I put in 2 commands here I'm encouraging you not to run. In the lab document, I show you how to manually set an IP address for a system. If you run this, your system will stop responding because it no longer has the IP address that was given to it by the cloud provider or the virtualization software or the network that it's physically connected to. I wanted to show you the format of that. Sudo ifconfig eth0, the IP address that you want to assign, the word broadcast, the broadcast address for that network, up. That's the first highlighted line. And that would assign that IP address to that particular interface, and it would take away any IP address that was already there, and that's the critical part. Please don't run that. If you need to use it because you just can't get a dynamically assigned IP address, and somebody says, hey, just assign it by hand, this is how you do it. Just don't do it normally. And the second one is route add default gateway, and then the IP address of your router leading out of the building. Those 2 will let you assign an address in an emergency. So we talked about how to go and tell whether our internet connection was live. Ping space -c space 5 -n 8.8.8.8. And sure enough, that system is responding, so I have IP connectivity. And to check that DNS is working, ping space -c space 5 -n www.google.com. And sure enough, it comes back with an IPv6 address, so I know IPv6 connectivity is working as well. I can put in a raw IPv6 address as well if I want to. So the quirky part of this, when you have, especially in a virtual machine setup, you may not be able to tell what IP address is on the outside world. And there's really no way to tell that from the system except from the system itself except to ask the outside world. Let me show you what I'm going to do. I'm going to send a connection request to a remote computer on the internet. Echo get space / is the command. Get space / is what I want to send to this web server. It's not technically fully compliant. There's a lot more I should be adding, but this web server understands what I'm asking and it will respond. Then I'm going to use the netcat command that allows me to place a generic connection to some machine out on the internet. In this case, the computer is icanhasip.com, and I'm going to connect up to port 80, the web server port. So I'm making the simplest possible web server connection you can make, and it's not technically RFC compliant, but it will work. Let's give it a try. When I connect out, this computer specifically knows that what I want is my IP address, because I don't know what it is. I actually do on a cloud server because I have public IPs, but on a virtual machine, I don't. What I have are internal addresses that start with 10.something, or 192.168.something, or 172.16.something. I don't know what my outside IP address is. With this simple command, I connect out through a gateway that replaces my internal address with the outside one, and then continues on to icanhasip.com, which is able to tell what my outside IP address is and reports it back to me, which is very kind of it. This is the easiest way to figure out what your outside IP address is if you're on a virtual machine and you just don't know what it is. Okay. Okay. Any questions so far, guys? Anything I should cover or review? Alrighty, I'll keep listening here. The last thing that I want everybody to be able to do is to see what's running on the computer. Easiest way to do this is called Pop. It's available everywhere. Pretty much every Linux distribution, Mac OS, and possibly even Windows, although I'd have to double check that one. Certainly every Linux distribution, every Unix-like distribution, and Mac OS all include this. Top shows you the running processes. And I have the screen a little bit thin at the moment, but if I open it up a bit, you see not only the amount of processing time that has been used by a particular process and the name of the process, but also how much memory is being used, in this case 13 megabytes of memory or 8 megabytes for SSHD. I commonly use one of two keystrokes. If I hit capital P while I'm running this, hold on a sec. Oh, it's already sorted by process time. The processes that are using the most processor time show up at the top. If instead I hit Shift M, capital M, it sorts it by the amount of memory actively being used by these processes right now. And so systemd-journal is using the most memory on my system. It is using 148 megabytes out of a total of 2 gigabytes. And then you can see the amount of swap that's being used, how heavily loaded the system is, how many days it's been up. So I've had this up for 3 weeks. I created this 3 weeks ago. Some basic system information. If you're really low on memory or the system's swapping like crazy or so on, this tool's always available. It's not the best for the job. We'll see another possible replacement in a moment, but it works really well. So Shift capital P to sort by processor usage, Shift capital M to sort by memory usage. And if I just type S it will change how frequently the display updates. I usually change it from the default of 3 to 10, and now it will stay stable for 10 seconds, then it'll come back and show me the next update in probably about 6 seconds now. Q to quit out, just like so many of these other tools. I'm going to do that now and get back to the command prompt. Hold on a second, I'm going to scroll back. Someone had asked if I could also cover, thank you, if I could cover SS. I will in just a minute. So we'll get to that in another module coming right up. My preferred tool is called ATOP. This one isn't installed by default, so you may have to go and type in apt space install space ATOP if it isn't, or yum space install space ATOP. This one's more interesting. And I'm gonna quit out and just restart it once more because I resized the screen and it changed the display. Hold on. ATOP, for the first about 10 seconds, it shows me all the cumulative activity since the system was booted. And the beautiful part about ATOP is that it gets down to individual processors, it gets down to individual partitions, it gets down to individual disks, it shows individual network devices. It shows how much read and write activity there is for a particular process. So systemd-journal, remember that was using a noticeable amount of RAM? Of course, it scrolled off the screen. You can see how much each of these processes have written to disk or read from disk. So in this case, systemd-journal has written 204K of data to disk. So if I have a hog that is writing a whole bunch of stuff to disk and I can't tell which process it is, I can come back here and see. I can also see how much network activity there is, how many IP packets in, how many IP packets out in general. But I can also see the amount of traffic in and out for individual network interfaces or individual disks. And so it's a lot more fine-grained. It really does help you identify hogs of network, disk, not so much memory and CPU, although it will give you overall CPU. And you can see CPU usage in this third column here, system and user process utilization. Well worth trying. Take a look at the ATOP manual if you want some more details about what each of these individual fields are, but well worth using. The final one that I want to show you is called GKRELLM, gcrelm. If you go to gcrelm.net, there's more detail about it. This tool's been around for decades, and it's really nice. And guess what? You've been staring at it the whole time. On the right-hand side of my Mac laptop, I'm running the Mac version of gcrelm on the laptop. Now, up here, I see the individual processors on my system, and in each of these boxes, I see the previous 60 seconds worth of activity. So this is CPU 0, CPU 1, CPU 2, CPU 3, 4, 5, 6, 7. I'm sure I miscounted there somewhere, but these are the individual processors on my system, and it scrolls from right over to left. So the most recent moment that was measured is right here, and then as you move over to the left, this is about 60 seconds ago. So I can see the previous 60 seconds, and I can see changes in pattern. So for example, this one down here is my Ethernet 4 wired Ethernet interface. And I can see there was a point where the network activity dropped dramatically. That makes me think that maybe I had a brief outage at Comcast. I never would have seen that otherwise. I can see the amount of free space, the amount of free swap, the amount of free memory. I can look at the activity for individual disks. So this is my main hard drive on the laptop. And then down below, I can see, for example, here's the wireless interface that's currently disabled. And here's my SD card reader, which is not active because I don't have anything plugged in. This one, it It may not be immediately obvious, but it tells you a whole bunch about your system. I can run this on a bunch of computers. At this one I have over just on the right-hand side of my laptop display, but if I've got 5 systems I need to monitor, I can run this remotely and have them all display their individual columns of traffic graphs and activity graphs just across the screen. Maybe I take an old disused laptop that's too old to do anything else, and all it does is show the output from GK Realm from 10 different systems on its little display. That I set off to the side, and now I've got a poor man's network monitor. It's really helpful. I can't tell you how many times since I've started using this that this has come in really, really handy for helping to identify spikes in traffic, fragmented files, someone on our network who started sending out port scans that shouldn't have. I literally saw one, a spike in traffic, and then I started looking up where that was coming from. I called over and I said, hey, let's call him John. Hey, John, how come you're port scanning the network? And all of a sudden it stopped, and he said, I'm not port scanning the network. Okay, thanks, John. Goodbye. It's really helpful to see all of that stuff and have everything in one very simple display. There are also plugins that you can add to monitor different things. Works on Windows, Mac, and Linuxes, and it's usually included in the Linux distribution, so you can quickly install it. Give it a try. I will show you how to run this, and I think that's coming up in a very soon in our output here. Give me just a minute, and I'll show you how to run this over SSH, and then you can give it a try on your own system. You need to have X Windows on your laptop to display this. So on a Mac OS, you can pull that off pretty easily. On Windows, it's tricky if that's what your laptop OS is. But we'll give it a try. We'll see how far we can get. All right, so if I could ask people, could you raise your hands when you are all set with this section? And we're just going to give it a couple seconds here for everybody to finish trying these out, and then we're going to go ahead and move on to the next section. If you've got questions, feel free to put them over in live chat. And if the people monitoring both GTM and live chat could let me know if there's anything I should cover, I'd appreciate it. All righty. Oh, we are getting a lot of people with hands raised. Thank you very much, guys. Great.
Hey, somebody asked if you would be covering TMUX today.
I won't.
Okay.
Excellent one to use. I really like that. TMUX and Screen are both two very handy tools for getting access to remote systems. TMUX is kind of the best of Screen and SSH merged together. I think that's just a little bit more than we can cover for time today. Anybody who's interested in being able to get access to a remote computer and do it in a very efficient way, it's kind of a replacement for SSH. So I would just encourage you to go and look into that. The TMUX homepage gives a good description of how it differs from SSH. Sorry about that, Sam, and sorry about that original poster. But I don't think we'll have time.
One quick question with that. Do you want me to go ahead? You wrote a really handy cheat sheet for a lot of these tools for active countermeasures, right? I think there's a blog post. Would you want me to share that into
the there's a
chat?
blog post. Would you be so kind? I'd appreciate that. Thank you.
Mm-hmm.
All right, everybody. We've got a lot of people who've raised their hands. There's still some who have not. I apologize. We've just got a few more minutes left, so let's just start in on the next section, and then we can take another 10-minute break after that. So I'm going to switch down to the section marked Signposts. The odd part with a command line isn't always easy to tell where you are. You have this big mass of files. The concepts here are very much like the first time you ever tried to make it around the C drive on a Windows system. well, this is just kind of weird. Why is there a C drive and what are all these slashes and why are they all staring at me? Let's just take a look. The first thing to understand is that on Linux, you have directories just like you do on Windows and Mac. And they have slashes between them. Differences that the Linux, Mac, and Unix communities all use forward slashes. Windows uses backslashes. Other than that, it's the same concept. You have directories, you have directories in directories. So if I type pwd, print working directory, I get an output that shows what directory I'm in right now, and that is /temp. If I go to the top level directory of the entire system, and I type pwd again, it shows me I'm in the top level directory. ls-al is how you commonly look at the list of files and directories in the current directory. And actually, we don't talk about it much, but dir works as well. If you just type dir, you get a list of what's in the current directory. It's got a lot less detail, and sometimes it's easier to read through that shorter output. So that's how to tell where you are. Did you notice something? When I change directory, so let's say if I just type cd, that says I want to go to my home directory. The prompt changes to a tilde. And tilde means the home directory of this system. Now, so I get this little hint that I can use to see where I am. And if I type cd space /temp, you notice how the prompt changes to follow along with me. So I've got a little hint there, but it doesn't always give me the whole path. So pwd is how you tell where you are. Okay. Doing this by hand is somewhat annoying, so I want to introduce a file manager that I've used since, oh my gosh, for 25 years in 2 different forms, and the current form is called Midnight Commander, or MC. Let me show you what this looks like. With I have to install it. Sudo apt install MC. Pull down files, think, crunch, crunch, and we end up with Midnight Commander. This is the easiest way to find your way around a system, because when I press enter on top of a directory name, like ... to go up 1 level, it goes up 1 level. If I want to see what's inside the home directory, I can see that there are 2 user accounts on the system. One's called lab user, one's called W Stearns, and I'm using the up and down arrows to move around. So if I go into the W Stearns directory, I can see that there are just a couple of files in here. And if you notice now at the bottom, there are some hints on this last line. Well, let me show you. The 3 down here means press F3. So if I press F3, I see what what's my highlight bar is hovering over. So this is a really, and double escape gets me out of that, so I'm back to where I was. If I want to copy this file over to /temp, I hit F5. And here I'm hitting F5. It says, are you sure you want to do that? And it copies it over to /temp, and sure enough, it's there. I can move up and down these 2 windows independently and look at different things and copy files around. This is definitely a worthwhile tool for getting around. If you catch me some night with a good stiff drink, I'll go and share the story of how instead of hitting enter on top of a directory name, I hit enter on top of the installer for a piece of malware in front of a class with a projector on the screen behind me where everybody could see that I just rooted myself. There's a little bit of danger, and keep in mind that the F8 key is delete, and F8 will delete whatever you have your mouse over. So just tread lightly, try some of the other keystrokes first. It's a really handy way to move around and to understand what's on a system. I want to show you one other thing real quick, and to do that, I'm going to switch back to my Mac laptop. So this is my Mac, and I'm going to, let's see, in the temporary directory. Thank you, Obi-Wan. I appreciate that. In the temporary directory, remember we copied the file Etsy services back? So here's that Etsy services file we were working with before. So I can see files down here, including some Wi-Fi logs I should take a look at sometime. I have no idea why they're there. But let me just put a little change to test 77. And so I'm going to hit escape 4. I turned off the hints screen below because I know what the keystrokes are. I save that, hit escape to get out. And then if I hit F3 again, I can see what was changed there. Now, I want to send this over to the Linux lab system. Oops, sorry, I can't do that. I'm very good at typing these quickly. F9 brings the drop-down menu. I'm going to look at the left panel by pressing L. And I'm going to come down here. I can either press H or hit enter on top of shell link. Watch what happens. I type in the name of a remote Linux system that's accessible by SSH, in this case Linux-lab, or you can put in an IP address. It asks me for my password. I type in my password, and now I see the remote systems directory tree. So if I want to put this in the, let's say, the home lab user directory, I hit escape 5 to copy. It says, are you sure you want to put it there? I hit enter, and it's over. So I can really quickly move files back and forth, copy things, delete things, walk around a remote computer's tree. That in itself is worth the price of admission right there. And of course, like all other open source software, it's free. So well worth trying out. Just a quick reminder, it's in the notes, but to get to this, I'm going to get out of this. Oops, sorry. F9 is the drop-down menu. L for the left panel. Shell link or press the H key, either way. And I'm going to go to a different computer. This is Devel. And I'm in, and I can look around at the contents of the Devel computer's home directory, all the directories there as well. So that's a handy way to get around the computer and move files back and forth. I'll quit out of here, and I'm back to a command prompt on my Mac. So that hint of moving around or making an SSH connection is in your lab document. It's in the signposts sections. Yes, Tiger, it is used for lateral movements. And there's also one other thing. I won't go into it right now, but there's an editor included along with this called MC Edit. It's basically very much like Nano. One of the really nice features is that if you're doing programming or writing shell scripts, it does context-sensitive highlighting. So if I go to a directory that has a script, and I type mcedit passer.py, you see that this is context-sensitive coloring showing what each of the items on this screen are. It's handy. Yep. Okay. There's my that was my side trip for the day. Well worth giving that one a try. The man page for MC tells you more about how that works. Down in the next section of your lab doc, I talk about the different directories that are used. The Linux community used to have a lot of differences in how directory trees were set up. And so one of the things that the community decided to do was to come up with a standard for where things should be put, so that if you go to one Linux system, they should look very much like another. In this next section down, I'm giving you a kind of a quick summary of the major directory trees used in Linux. And this is really a summary of what's called the File System Hierarchy Standard, or FHS. If you go down to the bottom, There is a link to the Wikipedia page on the file system hierarchy standard. Ubuntu has taken a couple of minor additions, really, not changes, but just additions. And so their Ubuntu tree is listed here under help.ubuntu.com. I'm not going to go down through each of these, but this is just a summary of what the major use of those directories are, so you can get a sense of why they're there and what you might find under them. Okay. And I think what we're going to do is continue on. Give a try to Midnight Commander if you've never used it before. Keep in mind that the function keys are all listed down at the bottom, and the way to get out of it is F10. Even if you're on a Mac, you can still use function keys. I have on my keyboard an FN, and so if I hold down FN and I press the 0 button, that gives me the equivalent of F10 on a laptop that has function keys, even if you don't have any. Or actually function and then F10 at the top of my screen. Escape 0 also does that function key equivalent. All right. Okay, so we're going to skip out of the signpost section and move down to SSH. As I said before, it's a little hard to come up with a way to truly introduce you to all of the topics in Linux and make it some kind of linear progression. You keep bouncing back and forth between this tool and this concept and so on. So we've done a little SSHing already. First thing to remember is that you need a machine to which you can SSH, and that one has the SSH server installed, and that server is listening on port 22 waiting for you to connect. So if I'm over on my Linux lab system and I type netstat, we'll see this in a future section, -anp pipeless. This shows me what the listening ports are on this system. And if I look down here, I have my SSH server listening on port 22, waiting for someone to connect in. Now, to connect to this, I need a client program on my laptop. Now, if you have a Mac, it's already installed. You can just type SSH space user at IP address and you're in. Same with Linux. The SSH program is always installed. It's there. If you have an iOS phone, there's an SSH term program, which is, I think, commercial. There might be a free version, but it's like $3 or $4 to buy. It's well worth it. Android has Termux, and you can then SSH from your phone to anything that will accept an SSH connection. Windows doesn't include one by default, but both PuTTY and the PuTTY program and the Cygwin environment provide an SSH client. So you can basically SSH from anywhere to anywhere as long as you have a server to SSH to. PuTTY is a standalone program. Cygwin is an entire environment that provides a lot of the tools that you find on a Linux system on the Windows environment. It seems a little backwards maybe to some people, but it's helpful to be able to use the same tools everywhere. Use PuTTY if you just need a standalone SSH client. So we've already seen SSH user at IP address. The user part is optional. If you leave it off, it's going to use the same account that you have that you're sitting on right now. So back on my Mac, if I type SSH space Linux-lab, it assumes that I am using the same account, W Stearns, that I'm on right here. If I want to use something else, I have to put, here we go. If I want to use a different account, I have to type root at or lab user at to override that. And in I am to my remote system. If I'm having trouble connecting, I'm going to log out of here. Let's come back to the Mac laptop, and I'm going to redo this, but I'm going to add the verbose flag -v. And what you're going to see is some very, very low-level information about exactly what it's doing. how it's negotiating keys, how it's trying this, how it, has figured out what IP address to use. All of this detail is painfully long and annoying. But if you're having trouble getting in, sometimes this is the best way to see that. There is a way to see on the remote server how to, turning on a verbose output for connection attempts as well. It's trickier. It's not easily done. We're going to skip that for this class, but it is possible. And when I'm finished with that connection, it will tell me just a little bit more detail about shutting down the connection and getting me back to my Mac laptop and how much data was sent and received and so on. Very handy. We already showed how to change your password, and we've already talked about running commands with sudo. The best approach with Linux is to log in as a normal user. When you have to run something as root, you think about it, you make sure you really need to, and then you type sudo space, and then you put in your password, not the root password, as you've seen all day, to be able to run something as root. I showed you a couple of times where I've logged in with a password, and then there have been a couple of times when I have tried to SSH over to the remote system, and if you'll notice, I logged in immediately, and I never had to type a password. So the question is, how did Bill pull that one off? It's the same remote computer. It has the same policy for both root and lab user, but I snuck in without having to type a password. How did I do that? Well, the answer is SSH keys, and I'd really like everybody to see this and consider using them. For a couple of reasons, it's more secure. You're not storing your credentials over on the remote computer, albeit in a slightly obfuscated form. This is a safer way to connect. It also means I don't have to remember my password all the freaking time. So here's what I do. In the lab document, I say, first of all, check to see if you have a key already. Don't run the command to make a key if you've already got one, because you'll overwrite the one you have. So if I run ls-al, starting at my home directory, go into the .ssh directory and look for any files that start with ID_*. In this particular case, I'm interested in ID_RSA specifically, and so I'm just going to look for that. And if you'll notice, I have a pair of keys, ID_RSA and ID_RSA.pub. And I have a second one that's used for a specific use called ID_RSA_data import, and the same file with .pub. This one, the first ID_RSA, that's the one that stays on my laptop. It never leaves. I never send that off. I never give it to anybody. When I want to get to a remote computer, I take the public file and I put that on any computer I want to reach. So the easiest way to do this, so first of all, if you don't have these files, and that's fine, you run the next block of commands inside the lab document. We make a directory called ssh.ssh. We protect it by making sure that nobody else can see it with chmod 700 ~/.sh. And then the final command is let's make a key that's getting stored in ID_RSA and ID_RSA.pub that is 3072 bits long. That's an SSH key. When you make that, it'll ask you, do you want to put a passphrase on it? Put a passphrase that you can remember easily, because you have to remember this one. And now the last step is to put that key on the remote computer. There are a couple of pieces to this. This is the easiest way I know to make that happen. These three commands in your lab document will pull down a shell script that will do the install for you. You make that script executable. Please take a look at it before you run it, because for all you know, I'm trying to get you to run malware on your system. I'm not, but I might be. And then you run the quick SSH key install that puts that key out on whatever remote computer or computers or accounts that you have. In this case, I'm asking it to put that key over on both accounts I have on the Linux lab system. So because I have this already in my path, I'm going to run quick SSH key install, and I'm going to put that key on both accounts on the lab system. I do this on my Mac. This is where the private key lives. And let's run this now. Going to ask me for my password. And then it tells me, yep, it looks like it was installed successfully. And it's also installed successfully on lab user. That's why, remember I told you I'd already done this once? So now when I type SSH root at Linux-lab, I'm in. No password request. And that's because I added this key to my laptop ready to go. There's one more step, by the way. In order to be able to use that key without typing your passphrase, you can tell your laptop to remember it. SSH-add space ~ssh/ID_RSA. Too true, BB hacking. Yep, I'll get to that in just a second. I can add this key into memory so that until I reboot the system, it's always available. And that's in fact exactly what I've done. If I do SSH-add-L, oops, sorry, I'm on the wrong system. Here we go. Back on my Mac laptop. If I list the keys that are currently stored, it shows that there are 3 keys available to me that I can send, that I can use to connect out to remote systems. All right. There is SSH-copy-ID, and if you want to look that one up as well, that is installed on, I think, probably every Linux system as well. I haven't used this as much, but I think it's very likely the same type of system. And so you can use that right now. SSH-copy-ID and then user at hostname. Thank you, BB Hacking. I appreciate it.
Hey, Bill.
Yes, please.
We also had somebody in the chat ask if copying with Midnight Commander is also encrypted like SCP.
Oh, perfect question. Yes, in fact, when you make that connection between Midnight Commander and you have one of those panes over on a remote computer, every single piece of communication between your local copy of Midnight Commander and that remote machine is done over an SSH connection. So that means that if you're using passwords to log in, you'll have to provide that password, and then it'll be an SSH connection from that point on. And if you are using keys to log in, it will automatically connect without having to type a password. So let me just show you that right now. If I start up Midnight Commander and I make a connection, if F9 left H, and then I connect out to Devel, if you'll notice, it's immediately logged in because I installed my keys over on that remote computer before. If I watch the wire while I'm moving up and down in directories and transferring files back and forth, and I'm doing all kinds of stuff on that remote computer, all I see is SSH traffic between my computer and Devel. Back and forth, back and forth, back and forth, until I quit out with escape 0 to quit Midnight Commander. Thank you, Sam. Excellent question. Yes. There are, I think this used to be let you do this over RSH as well. Don't even ask. Just let RSH slip from your mind. This really needs to be an SSH connection. Okay. That is the whirlwind tour of SSH. And I covered quite a bit there, I grant you. There's a lot to learn, but this is kind of the absolute bare minimum that you need in order to be able to connect up with SSH keys. Once you have those keys set up, then the Midnight Commander feature we just looked at, logging in with SSH, transferring files with SCP, and using 2 other tools called SFTP and rsync, which can both also operate over SSH. All 5 of those tasks can work immediately with the remote computer with no additional login needed. So if you're working with tens or hundreds or more of machines and you need the ability to very, very quickly connect, run a task, and disconnect, connect, run a task, and disconnect, this will save your life and save your sanity. Trust me. Alrighty. Now, I told you I would show you how to run graphical tools with X Windows, with SSH and X Windows. This is a little bit tricky. On a Mac, you need to have the Xcode package installed, and I'm going to refer you back to Google for that. It is an extra package. The install takes a couple of steps. It's not something I can easily automate, but once that's in place, let me show you what happens. Over on the Linux Lab system, I'm going to say, is the Xterm program installed? Now, it isn't by default, but when I type which Xterm, it's something that I did install yesterday. So when you want to give this part of the lab a try, you're going to have to run sudo apt install Xterm. Now, I already did this, so it's going to basically return and say, yep, it's there, and it's the latest version. When you do this, there are a boatload of packages that have to all come in for this to work, and it's going to take a little while. It's worth doing. Let it run in the background while I'm showing you the end effect of this. Xterm is a graphical application. It sets up a window. It's got borders. It's got clickable buttons. It's got the file menu. It's got all kinds of stuff that you expect from a graphical tool. But I don't have a display on a virtual machine to show it. I don't have a display on a cloud server to show it. But I'm not out of luck. We're going to go back to the Mac laptop. The second piece of this is that I want to SSH to Linux-lab, and I want to run that graphical program. Now remember, SSH is text-based. SSH doesn't really know anything about moving graphical displays around unless I tell it to. So this Xterm program, if I didn't tell it otherwise, it would be kind of lost. But I'm going to give it one more command line option, and that is -X. What that says is, go to the Linux Lab computer, run the program called Xterm, and tell it when it has stuff to show on the screen, don't show it on that remote computer, pull it back to this laptop and show it on this screen. Watch what happens. It takes a little longer to start up. There's a whole bunch of things that have to get loaded into memory for this to work. But within 5 or 10 seconds, we should have a graphical application show up on the Mac display. This is a command prompt that happens to be over on my remote computer. In fact, all of the display processing, except showing the actual pixels, is being handled on the remote computer. The pixels are coming back to me. It's a little bit more subtle than that, but it's pretty close. Now I've got a command prompt that I can use to type commands like ls-al. Sorry for the font size, it's very small and I don't know how to go and increase it. ls-al/temp, and up comes a directory of /temp. So here's what happens. It's an application that's running on the remote computer, and the display and the keystrokes and the mouse movements, even mouse movements work, are on my laptop. So this is the way you run an X Windows application, and you pull it back to your screen when the remote computer doesn't have a screen to show. You can kind of get one to show. You can set up a whole desktop on a virtual machine. You can't do this on a cloud server. So I had a customer in Oregon that needed a UPS setup on a computer that I'd sent them, but the only tool to set that up was a graphical application. So I SSH'd into them over a modem connection at their end, ran this approach, and it took about 15 minutes to get all of the menus back and forth over this silly modem connection. But I had to use this one tool. It's the only way to make it happen. So I'm going to go and exit out of here. And you notice that back on my Mac, I get this command prompt back. Once the extern program said, I'm done, I'm exiting, I'm all out, then the SSH connection closes as well. But let me show you one more. Let me see if GK Realm is installed on here. Which space GKRELLM tells me where can I find this in my path. And it turns out it is installed. If you don't have it installed on yours already, sudo space apt space install space GKRELLM will be enough to install it. So you have to get this installed first. Now I'm going to come back to my Mac laptop and I'm going to run GKRELLM over on Linux Lab, but pull the display back to me. Let's see what happens. Again, it takes a couple of seconds to set up the basic display. It gives you a quick introduction screen because it's the first time I've run it. And it says if you press F1, then you can get into the setup for this display. But you'll notice this copy is the one that's running on Linux Lab, and I'm showing the display over on my Mac screen. This is what X Windows applications are, and this is really handy if you've got a graphical tool you want to run. Warning, you're sending screen updates over the wire in a really heavy network usage. Don't use this for something like playing a live video where the processing is done on the remote box and you're carrying the screen updates back to you. That's a massive amount of traffic. It's going to be slow and sluggish and you're not going to enjoy it. But for normal applications where you're pressing function keys and you're dragging this around and you're selecting text and making it italic and so on, it's just fine. It works really well. Just for grins, I'll show you F1 on this. This is the configuration interface for GK Realm. And here I can go in and turn off, let me say, for example, I don't really want to see this mail icon because I don't get mail on that system. I come down to the configuration area marked mail and I uncheck enable mail check and it disappears from the screen. Okay. So that's GK Realm, and it's handy to be able to run this on multiple servers. Just find, as I said, an old laptop or desktop machine that's so decrepit that you wouldn't want to run anything on it. Start up GK Realm, connect out to 4 or 5 different machines, pull the display back to this one, and now just leave that running. Now you can just look over every once in a while and see how things are going on each of your servers. And I'm going to hit Control-C on that. That kills the SSH connection and kills GK Realm as well. Hey, thank you, everybody. This is kind of it's an esoteric tool and technique, but it's really handy sometimes. And it means that you've got options even on a remote computer that has no display. There's some more references on SSH in the O'Reilly SSH book. I have a blog post on how to go and set up that Linux Lab thing so you don't have to type in the IP address every time. I encourage you to use that technique if you're going to use SSH for anything more than just the simplest of connections. All right. To generate SSH keys from Windows, that depends on the application that you're using. If you're using the Cygwin environment that I mentioned earlier, the SSH-keygen tool that's in your lab document works perfectly there. If you're using PuTTY, then you go into PuTTY's configuration. I don't know where to look, but PuTTY does have the ability to generate SSH keys, and you can also install them on the remote end as well. All righty. So if people want to raise your hands, are people ready to move on to a new section? If so, could you raise your hands? And like I said before, even if I move on to a new section and you want to still keep playing with the old ones, please do. Absolutely. If you miss anything that I said, remember you've got a recording that'll show up in about 2 weeks, thanks to Ryan's wonderful work. Okay, great. So let's move on. Next one is packages. We've already run apt a couple of times to install both a group of packages and also individual packages. So we've used this already quite a bit. Let's take a look at what's currently installed on the system. The command for that is over in your lab document. The basic piece of it is sudo apt list. But I want to restrict that to just the packages that are currently installed on this system. So I do sudo apt list -- installed. And if I feed that in to less-s, as I commonly do, what you see is all of the installed packages. Their names are over on the far left. I think this is the distribution that's being used. This is 20.04. Here's the version that's installed and some more details about it. But really what you're interested in is that the add user package is installed and ACL is installed. And if I do a /gkrellm, sure enough, there's a package called gkrellm installed. So that's how to tell what's already on the system if you're looking for something. We've done installing, I did include on the Fedora, CentOS, RHEL, there are a few others that are based on RPM, SUSE and Mandrake and so on, Mandriva. If you're doing the same thing over there and you want to see what's installed on those, the equivalent command is rpm --qa pipe sort, and that will show you the installed packages on those. If I want to see what package owns a file, this gets just slightly trickier. The easiest way is to do a search. So I'm going to show you that one first. apt search nginx. This is a commonly installed web browser. It's Apache's HTTPD is the other. But let's just see whether that package is available. And so when I do apt search nginx, I get a whole bunch of things that reference nginx, probably down in their description. But if I scroll down a little bit, sure enough, there's the nginx package already available as part of the operating system. And if I note over here, it says, oh, by the way, it is installed. I did this a couple of days ago. But that apt search is the easiest way to find them. If you're saying I want to find a particular executable, then I'm going to look for the rsync binary and see what package might own it. I don't know where rsync is located, so I'm going to just do search in all of the common places for them. So I'm going to use the dpackage command -s, and then I'm going to list the places where I think it might be stored. By putting asterisks in front of and behind it, then that says anything with rsync in the name, I'll go for it. And when I run that, what comes back is that rsync shows up as both rrsync in user bin and rsync in user bin. Actually, I'd never heard of rrsync. I'll have to go look that one up tonight. Don't know what that is. Now, so these are the ways to kind of figure out what package owns it. You'll find a number of times when you're working with Linux systems where you'll have to go back to Google and say what package name rsync Ubuntu 20.04 or something like that and do a little bit of searching, but it's usually available. I'm trying to show you what you can do on your own system to do basic searches. There's another one, if you're on the Fedora or CentOS or RPM-based RHEL side, you can do yum provides *bin/rsync. That says, tell me what packages provide that resource. And you can also do, just like with the app side, you can do yum search nginx. and it do basically the same thing as apt search engine. When it comes time to install the package, we've done this a couple of times already. Sudo apt install, and then the name of the package. On the Fedora and CentOS and RHEL RPM side, that's sudo yum install package name. Yum is technically deprecated. It's supposed to be removed at some point. I'm sure it will. Yum is a package manager that's been around for, I think, a few decades now. It's been replaced by another package called DNF. And the reason why I'm still giving yum commands is, one, they still work. And two, yum is very, very prevalent in the RPM distribution, RPM-based distributions. So even the newest ones that use DNF, they will almost always allow you to use the old yum commands. And I know that's a terrible habit to get into, but if you want to use the newer one, pretty much everything I've said with yum, you can verbatim replace yum with DNF, and it will work just fine. When you're done with the package, on the Debian and Ubuntu side, there are two steps to it. So I'm going to show you, let's first off install a package that I know I'm just not going to use for today's lab, but let's show you how it's done. Sudo apt install Alpine. And this is a mail and Usenet news reader. It's actually kind of a handy mail reader. I use it over on another computer for another account. So we'll put that in place. It will need to install all of those packages, pull a few down, do its normal thinking and crunching in the background. And what I end up with is the Alpine executable is over in user bin. And if I do a search, if I do that list installed approach and search for Alpine, sure enough, Alpine is installed as well. Now, when I'm done with this package and I want to get the space back, I can remove it. So instead of apt install Alpine, I'm going to use apt remove Alpine. Now watch what happens. It says, hey, I'm ready to go and remove this one package. And it says to me, now be careful. In order to install Alpine, I had to put in separate packages called mlock and alpine doc that support it. But I'm not going to delete them unless you specifically tell me to. Either way, it doesn't make a big difference. This first step will remove Alpine only. So I'll finish that process. We will remove it. It'll pull those files back out. And now when I get back to a command prompt and I say which Alpine to say, tell me where the executable is, there isn't one. It's gone from the system. But we still have those supporting libraries. So I put the second command that you need to run also in the lab doc, and that's sudo apt auto remove. You don't have to remember that. In fact, when I removed the Alpine package, it told you if you want to remove the libraries too, run this. So here's that sudo apt auto remove. And it'll say, great, I'll pull out those two supporting libraries that nobody says they need anymore. I say yes, and out go those two files as well. You don't have to do this, but it helps to keep the system clean, pull off all the stuff that you don't need anymore. And so I'm just showing you both steps. Over on the Red Hat side, it's sudo yum remove package name. And I am almost 100% certain that it will remove all the dependencies as well. Yeah, we'll call that 99.8% certain. It pulls out the dependencies. Okay, so those are the major things that you'll need to do with packages on your system. Linux distributions tend to be very complete. Even if the disk that you do the install on doesn't include everything, they know how to go out to the internet to look for the latest versions, to look for the patched versions or have had security updates, pull those down. They're feature rich in the number of applications that you can install right from the apt or yum interface. So I encourage you to give this a try. And if you're just looking for, graphical tools or photo editors, you do apt search photo, see what you find. There's some references here, different pages talking about the different formats and the different tools that are available. Go ahead and take a look at these guys. There's some cheat sheets on how to use apt and some of its advanced features. Well worth it. In the Debian and Ubuntu worlds, we talk about apt, and it's a relatively low-level package. It handles dependencies. But there's a graphical tool called Synaptic, Synaptic. That's worth installing if you want to do this from a graphical desktop and do point and click. DNF I talked about already, and RPM is the even lower-level package management tool that goes along with Yum and DNF on the Fedora CentOS RHEL system. Okay. Let's move on. I think we've got enough information on those. If you have questions, guys, any questions coming in from either the question side of GoToMeeting or Discord that I should look at? It's sounding pretty quiet.
Yeah,
Okay.
I think we're good for now.
Sounds great. Thank you, Sam. All right. So we already talked about copying files back and forth. We showed you this syntax here with putting a file over on a remote system and pulling it back. I like the idea so much, I included it in 2 different places in this particular lab. I'll have to clean that up later. There's another tool called rsync. And rsync, if you think about it, if you replace scp-p with rsync-av, that also can send a single file back and forth over the SSH connection. But rsync does one more thing that I want to show you as well. Forgot to make that courier text. So let me just show you, first of all, how to send an individual file over to the Linux system. And you would do this, hold on, let me do this on my Mac so that you can see how you would do this from the Macintosh. Here's the local file that I want to send. Here's the remote computer that I want to send it to, which in this case is Linux-lab. And then finally, what directory would I like to place it in? It's very much like SCP, that I'm sending a single file over to the remote end. rsync, you can look up the command line parameters, but the usual way to do this is rsync-av to make the permissions look the same on the remote side. And you always have to include -e SSH to say, hey, by the way, use SSH as your carrier. There's another format for it, but most of the time you want to use SSH. rsync goes one step further, and I want to show you this briefly because it's important. I'm going to make a target directory over on my Linux system, and I'm going to call it here junk. Okay, cd junk. And if I type pwd, it shows me that, yeah, I can do this. I'd like to do this as the lab user account. Hold on a second. I'm going to log in as lab user on the Linux lab system. And we're going to make a junk directory. And so this directory I'm in right now is home lab user junk. Now, if you notice, there's nothing in there. That's empty. What I want to do, let's go back to the temp directory. There's a whole lot of junk in here, but I want to copy all of this stuff. Do I want to copy all of this stuff? I have 60 meg. Yeah, let's do this. This will be fun. I want to copy the temp directory over to that remote computer, and I want to make the remote directory junk look exactly like this. I don't want to have to go and individually specify all of the files. I don't want to have to specify all the directories. I just want it all this stuff to end up over there. So to do this, the syntax is down here. It's under the label making the second directory look like the first. So the way to do this is I'm in /temp. I do rsync-av-essh /temp /. Make sure you end both of these with a /. It's actually important in this one particular command. I want to send them over to lab user at linux-lab /home/lab user/junk. Now, let's just double check. I'm in home lab user junk right now, and if I do an ls-al, there's nothing there. Now I run this command. And because both of these end in a /, I'm telling rsync, take everything you see here and make it show up in here. All right, let's run it. And off go those files. It's 55 meg worth of stuff. And if you'll notice on GK Realm, I can see that there's a spike in traffic as this stuff is heading out to Linux Lab over on my Ethernet interface. Now, if I go back to the home lab user junk directory and do an ls-al again, sure enough, all of these garbage files and these things that are just temporary files and need to get deleted sometime are all showing up on the remote computer. They're getting copied over. And when I'm done, these two directories will be the same. And that's the magic of using rsync. It says, I want to take a master copy and I want to have it show up somewhere else verbatim, as close as you can. The only thing that this won't do is if I've deleted a file, if I delete 10 files from my Mac, and I run this command again and say, hey, make the other end look like mine, it doesn't automatically delete those files on the other end. To say, not only do I want to push this stuff over, but I also want to make sure that I delete anything on the remote side that got deleted on the local. Guess what the command line parameter is? -- delete. So I add that to that and I say, I'm trusting you that I've got this command correct and I want to send over these files, but I want to make sure that the remote end, I delete the file from the remote end. And so it's going to go through. Now, you notice how quickly that happened? It actually talked to the remote end. It took a look at all the files underneath those two trees, compared them and said they're the same, and it's done. So it will only send over the changed portions of the changed files. rsync is blazingly fast that way. It's a great way to get a tree of files to look the same on the second computer as it does on the first. So just a real quick recap. rsync is the program. -av says keep the permissions as close as you possibly can. ESSH says carry this all over SSH. /temp is the local master copy. This is the one you trust. This one doesn't get modified at all. This is the remote directory that we want to update and make it look like /temp. And the final one is, hey, if I deleted anything on the remote end, make sure I delete it on the, if I deleted anything locally, make sure I delete it on the remote end as well. And that's really the beautiful part of this tool. I've got 301. If you've got questions, let's.
There you go. I do have a question. And actually, it's a very good question that I'd like you to answer.
Yeah.
Question is, what about the file permissions? Are they also the same? Is there no inheritance?
Yes, the file permissions are the same. So the user owner, the group to which the file is stored, the permissions or the mode of the file, all of that is sent over, assuming that you have those users on the remote end. So if I have files in /temp that are owned by user K Chu, but there is no K2 account on the other end, then they'll show up with what's effectively a random user ID. That's the only time it doesn't quite work. But if you think about it, what option does rsync have if you don't have that account name on the remote end or that group name? That's the -AV. Actually, it's the -A that preserves all those permissions. V is just verbose, show me exactly what you're sending over. Excellent question, Keith. Thank you very much. We got one more section to go through. Thank you so much for all of your attention so far. It's been a lot of fun teaching. Let's go and finish up with just a couple more sample commands that you really should know for getting around on a Linux system. One is I need to be able to pull down a file from a web server. So in this case, we're going to pull down a file onto the Linux lab machine. So let's go back to home. If I do pwd, it shows I'm a home lab user. So let's make a downloads directory, mkdir, as opposed to md, I think is what you can use on DOS. It's mkdir. I have to go into that directory as well. And now if I look at where I am, it's an empty directory and it's home lab user download. There was let me cover a question from Tiger. Since rsync is blazingly fast, is it used for digital forensics purposes to copy log file directories from a live target system or to exfiltrate large directories from the target system? Sure, absolutely. rsync does a couple of things. It will compress the files. It will send only changed or new files, so old ones just get left as they are. You don't have to send them twice. If you have log files in particular, think about log files. I've got this block of stuff that I've already sent over to the target system, and now there's this new section at the end that I want to send as well. rsync says, oh, on the target system, I've already got these lines, no need to send them again. And it just sends this new block of stuff to append to the end, essentially. It's slightly more complicated than that, but that's effectively what it does. So it's a great way of sending files that may change over to a target system without having to send them all every single time, which is what SCP would do. It just blindly copies everything, even if what's on the remote system is identical to what's on the local system. Great. Alrighty, so let's try a couple of downloads. In your notes, you've got the references for two programs. The first one is called curl, and I'm going to kick off that command with curl --s, the silent mode. I'm going to download a file called downloadme.txt from Bill Stearns' web server, and I'm using --O to say save it with the same file name that you downloaded it under. When I run that, nothing shows up except for a file called downloadme.txt. And if I cat downloadme.txt, I see that the file has come down. So curl is one that's very commonly on Linux systems. I'll give you the other one that's called wget. It's a slightly older one. Still very capable, and I'd love to have you know how to use both in case you need to download files. In this case, you use -Q to be quiet, and then by default, wget will save the file under the same name that it was downloaded as. So I should end up with, if I do ls-al, a downloadme2.txt, and I get the second file pulled down from the web server as well. Just handy if you need to get something from a web server. If you want to see a remote web server, there are two command line web browsers, primarily for Linux. The first one is called LYNX. And so if I use that web browser and I go to www.google.com, it's going to ask me about each individual cookie, or do I want to do these? I'm just going to hit V to never save cookies. And what I end up with is the text version of Google's homepage. I can even come down here and search for Black Hill. Hills Information Security. Google search. And sure enough, the first link that comes back, I'm very glad to say, is Black Hills website. You hit Q to quit, and then you say Y to make sure that you really do want to quit. That's links. Now, there's a second form. It's a totally different program, but they decided to make things really confusing and call it LINKS as opposed to LYNX, which is what we just saw. And I'm going to go to just a different web server, www.whitehouse.gov. Links is not installed. So sudo apt install links. And in it goes. And once that's in place, I have a second web browser. Welcome to Links. And up comes the White House's text version of the website. Would you want to use these for a lot? No, not really. But it's really handy if you're stuck there with a command line and you have to pull something down from a web server. It's just nice to know that you can. Okay. I'm going to give the world's shortest tour of Nmap. Nmap is the mapping tool that tells you something about the remote system that you're scanning. First is get permission first. Don't just go out and blindly start scanning remote computers. You can get in a lot of trouble for this. Maybe it's as simple as getting your internet access shut off for a week as a punishment. Maybe it's getting it canceled. People have lost jobs for trying to do what they think are security tasks without permissions. Please don't. So what we're going to do here, and if you'll notice, I've set up an Nmap command line. And I'm going to run this command line, but I'm going to do it on the IP address 127.0.0.1, which is always my computer. Whatever computer I'm running it on, that's what we're going to run it against. So because we're doing this on the Linux Lab system, we're going to scan this computer. I'm going to put sudo in front of it. And just quickly, -A says, give me basic information about operating systems and versions and so on. When I say -- top ports 40, it's going to look at the 40 most commonly used ports on the internet. I don't want to do all 65,535, but I do want to use what's called a connect scan, which is -ST, saying connect to the port, tell me if it's open or closed. And finally, this is the only IP address that I want to scan. I can put multiple host names or IP addresses on that command line, IPv4, IPv6, it doesn't matter. So once I've got that all in place, then the last thing is I want to feed that into ~S so that I remember it. Nmap version 8 tells you that it started at a certain time, and it's going to take just a minute to figure out what's on the remote computer, which is itself. Remember, Linux Lab machine is scanning itself. Out of the 40 ports that it scanned, 38 of them were closed, nothing there. But it did find two things of open ports. First is the SSH server is on port 22, and it gives you the full description of that service. It also found an Nginx web server on TCP port 80 and showed you the version of Nginx as well, 1.18.0. How does it know that? Because it's sent back in the headers. The server itself says, hi, I'm Nginx 1.18.0. I'm running on Ubuntu. What can I do for you today? And it waits for the client to send over a request. Based on the scan, it's also able to make a guess that this is Linux 2.6 kernel or higher. It can't really tell down to the individual release exactly what version it is, but it tells you it's probably a Linux machine. And some more details about how far it is away. You notice this is 0 hops away, meaning that it's immediate. I'm sending a packet and I immediately get a response back without having to go through multiple routers to get there. This is the simplest version of Nmap, and there are tons of things you can do with it. You can get really esoteric. You can script it. You can pull the reports out in text, HTML, XML, I think, maybe even JSON. It's been so long. There are a ton of things you can do with it. So that's the basic use of Nmap. The one thing we didn't do in that command was to look at UDP ports. The difference with TCP and UDP, TCP is a connection, and I can guarantee that if I can make a three-way handshake that I can talk to the other end. UDP is, let me throw a packet at the other end, and maybe it responds and maybe it doesn't. So scanning UDP ports is actually really hard. If I want to do that, let's do that with sudo in front because I need that privilege to do this. And I change this to -S that says scan UDP ports as well. If I scan this, it's going to take a couple of seconds to even come up with basic answer. And it only found one open port out of the 1,000 that it scanned, which was 5353, which is used for zero configuration DNS requests. It's fast on the loopback interface. On every other interface you'll ever try to scan, it's going to be a lot slower. Just accept that. UDP, I won't get into the details of why, but UDP, you can't scan quickly. It can take an hour to do a full UDP scan or more. So, if you need to know for certain what ports are open on another machine in a network and you want to be able to do that type of scan and you've got permission, Nmap is there and it will gladly help you. It's not so useful on this local system because obviously I can use tools like Netstat to show me what ports are open. And in fact, that's the next section. Let's switch over to that now. I'm going to use a new tool called SS that shows me the open ports on my computer right now. Let's do the basic lookup, which is sudo space SS space -P. And when I run that, I get a whole bunch of information about open, not only ports, but files as well. So this gets a little bit hard to read, but I can see for every individual program I'm running, what ports and files are they holding open. What I'm really interested are the UDP and TCP ports. And down here, for example, I can show that there's a connection between my computer's port SSH and some other remote IP address that I won't show you because it's my home address on this output. You'll probably see it before we're done with the lab, but let's assume you won't. The other way to do this is to look at the TCP connections and get some more data about the network connections. So let's give this a try. Sudo ss space -tuanp. It's a common way to run it. And sure enough, yep, you get to see my home address. Please don't attack it. It'll be a very short webcast today if you do. Here are the ports that are open. These are the UDP ports up top. And here are the TCP ports down below. And you'll notice that I've got something listening on port 80, which is Nginx. I've got something listening on port 22, which is the SSH server. I've got something listening on the loopback address for port 53, and this is part of the resolver on the system, the DNS lookup. Because these are : these are IPv6. Because these are 0.0.0.0, I'm listening on IPv4 as well. So I can accept connections on either IPv4 or IPv6, port 80 or port 22. SS was really handy for being able to tell what programs are listening on ports. Why do we care? Well, the reason is when you want to lock down a system, you want to shut down any services that you don't need, especially the ones that are listening on a port. Those are the ones that are vulnerable from attacks in the outside world. If you have a program that's running, but it has no listening port, you can't directly attack it over the network. So these are the ones I'm really concerned about. These are the ones I really want to keep patched. Now, there's some other forms of this. I'll just briefly show you netstat. Oops, sorry. That's not what I wanted. There we go. So netstat has very similar output. It's just organized differently. TCP version 6, UDP version 6, TCP v4, UDP v4, and then what ports are listening, what connections are made, who's connected. We've got somebody from two totally different IP addresses connecting up to our SSH server. Somebody's brute force attacking me right now and trying to connect and log in as root. This is what you find when you run a Linux system out on the internet. We'll see those in a log in just a minute. All right. Running processes, we already talked about sudo ps space axf. I'll run it for you once more. This is where you see the forest view, where you see all the processes in a hierarchy showing what program started what program. That shows you the running applications. But I also wanted to show you how to start and stop individual services, because it's helpful to be able to lock things down by turning off unneeded services. To see what's available on your system, we can run sudo system control -- all. System control is the commonly used management. It's called the init daemon. It's the one that starts up the system, that manages what runs by default. And I've got to do this with less-s because it scrolls all around. These are all of the things that get started as the system is started, and there's this whole hierarchy. I've got to have this in place before I start this, and I got to have this in place before I start this other thing. System control handles a lot of your system right now, but these are all the individual objects that can be started with system control. Most of what we care about are the services. So if you scroll down here, for example, I see there's an object called nginx.service. And this is that web server that we've been seeing all day. I can turn that on. I can turn that off. Let's take a look at how that's done. There are a couple more examples. There's system control list unit files is the next command down in your lab doc. There's also an older version. I just wanted to include it for completeness, called service. And this was what you used to use. At this point, service is more, it's a compatibility layer, but it's not used as much as system control is. This is how you would list all of the available services with the service command. So once you've got nginx installed, sudo apt install nginx, I can start it or stop it. But first of all, let's see if it's running. The way to do that is to check with status. And I managed to stick that down at the bottom end of the list rather than the top. Let's see if it's running at all. Sudo system control status nginx. It's listed as active running. It's running right now. And the other thing to note is that it's disabled, meaning the next time I reboot this server and I come back up fresh, nginx will not be running. Disabled means don't start on the next boot. Enabled means start this on the next boot. And those are totally independent from start and stop, which start it right now or stop it right now and don't have to match what happens on the next boot. So maybe I found that I don't want to have it running right now because I'm getting a network attack on port 80. So I can type sudo systemctl, and this is stop nginx. When I run that and I type sudo systemctl status nginx, look what happens to the output. it changes to inactive dead, saying, hey, I'm not running anymore. It also gives me a couple of lines from the Nginx log so I can see what happened or why is it stopped. And then if I want to start it back up because the DDoS attack has now stopped, sudo systemctl start Nginx. And if I do status, keep losing my cursor here, it shows active running once again. If I want it to start on next boot, sudo systemctl enable Nginx. Changes a couple things. And I do status again, and it changes to enabled. So if I typed reboot right now, the system would go down, and when it comes back up, Nginx would get started automatically on boot. This is what you need to know in order to be able to turn on or turn off services. We've already told you how to find a given service and what services are listening on network ports. Here's how you go and turn them off right now and how you disable them on future boots. You need both of those commands in order to turn something on now and make it available on the next boot. Okay. So if you want to try this, you can always use the Lynx web browser, LYNX, if you have it installed. Let's take a look right now. LYNX, http://127.0.0.1. My IP address. I'm going to go right to myself. And you get back a status page from that Nginx is installed saying, yep, you're here. My user didn't actually put anything for you to see, but I'm here. I'm a web browser or web server, and you're here. Okay. If I turn it off, with sudo system control stop and Nginx, and then I do the Lynx command, I get alert, unable to connect to remote host. There's no web server listening anymore. There's nothing listening on port 80 to accept that connection. So you can use something like Lynx or wget or curl or links to actually connect to that port and just make sure that everything's running the way you expect. Okay. I'll show you one other, but we're going to do it relatively straightforward. This is where you have two connections. You'll need two connections open to your remote system. So I'm going to SSH to Linux-lab, and I'm going to show you how to set up your own TCP connection between two windows. Remember, I'm logged into Linux-lab on both computers. So the first thing I'm going to do is I'm going to start up a program that's going to listen on port 999. Okay, it's listening on port 999. What's it doing? It's waiting for something to connect, just like a web server waits for a web client to come in and talk to it. Now, in the other window, I'm going to connect to myself, port 999. Let me go and shrink these down so you can see both at the same time. The second copy of Netcat is going to connect to the first. Okay, did it connect? Let's find out. If you'll notice, I typed good day down here and it showed up on the remote end. If I go back to the other end, anything I type there shows up on the other end. So this is a two-way connection. Anything I type in one shows up on the other. This is the basic tool for transferring data back and forth. Netcat is a very, very basic tool. And all it does is connect up to a port, and what you type in on the console goes out to the server, and anything you get from the server comes back and shows up on your screen. And in this case, we have two copies of Netcat talking to each other. The -L up here says, hey, listen on port 999 and wait for somebody to connect to you and then transfer data back and forth. Down here, we said, hey, connect up to the loopback IP address, port 999, so that you can talk to that other copy. They're both running on the same machine, but nothing says you can't run it on two different machines. So I'll leave this second one for you to try yourself. You can do this with those two commands in the last section on your laptop and on your Linux lab server. Run the first one up on your Linux lab server. Run the second one on your laptop. And the reason I say that is, you know you can make a connection out to the Linux lab server from your laptop. It may not be the case in the other direction. So make sure you have Netcat installed on both computers. If you don't have them installed on your laptop, that's okay. We can still do them both on the Linux lab server like we did up here. I have a reference to Netcat and how it works up down in the references area. It's got a little bit more detail about how Netcat works. Is this something you want to use every day? No, but it's a really good troubleshooting tool. It can tell you that you can make a TCP connection between two computers successfully, which helps you identify problems with maybe a firewall or something else. Okay, there's also a reference on how to use SS on Linux as well. Feel free to go and take a look at that if you want some more details about how that works. We've got 23 minutes left, and I am going to just briefly take a look here. I'm going to change the order a little bit because I have a couple sections I want to make sure you see. So we're going to skip, for the moment, network topics. There's a lot in there, but there's nothing that I think you have to know for this. I'm going to skip packets as well. Let's come down to locking down the system, and I want to cover that and common problems, and I want to make sure we get those two done before the end of the day today. All right? So scroll down, I think it's about 3 pages, to locking down the system. Might be 4 pages. Let's see, 1, 2, 3, 4, 5. Down 5 pages to locking down the system. I have that as page 26 on my copy. All right, everybody with me? When you're working with a computer, it's nice to think that maybe the guys who designed it put it into a relatively safe state to start with, and that's generally true, but it's not universally true. So I want to cover on a Linux system, what are the major steps that you need to do to make it secure, to lock it down? One is to work with a firewall. And because we skipped the section above on firewalls, I'm not going to go into too much detail on that right now because we needed some background in order to see that. You can see the sections above on firewalling, and we may be able to cover this in a future webcast. But for the moment, there's a tool that comes with Ubuntu Linux called the Uncomplicated Firewall, or UFW. There's a graphical interface to it called GUFW, and that one is a little bit simpler to use, but neither is all that hard to use in general. I show some examples in the previous section that we skipped over of how to, for example, block traffic to an incoming port, or block traffic from an attacking IP address. The command lines to do them are not terribly complicated, but they're not really straightforward either. So UFW and its graphical version, GUFW, are a much easier place to start. If you need to run a graphical tool, obviously, you can still use that SSH-X trick to do it. It's relatively straight to do. The second thing, like every other operating system in the world, is to make sure you keep it patched. And we tend to leave this one and assume that the OS is going to do it for us. It kind of isn't. So if you need to do this by hand, we have the 3 pieces that you need overall: apt update, apt-y upgrade, and app-y auto remove. Remember we talked about how to go and pull out the libraries that were no longer needed? We added that into the command right here. If you want to have automatic patching, just have the computer do it for you. Great, please do. There's very little risk. I can't say there's no risk, but this isn't the nail-biting activity that you get on Patch Tuesday when Microsoft comes out with something and you're not quite sure if it's going to screw up your system. It's always possible for that to happen, but I have to admit it's relatively rare on Linux. And so I don't have this kind of ongoing concern every time I install patches. The way to do this is to use a package called unattended-upgrade. Install that package. And by default, that will go out and it will grab the critical patches and just put them in and be done with it. That's the simplest way. If you want to go and look at more details about the package and how to go and decide exactly which categories of software you want to install, that's great. But by default, it puts in the base packages and the security upgrades as well. If you've gotten to a point where you're using SSH keys for all users, you can actually go through and turn off password authentication entirely. Make sure that all the users are all set and that you have root privileges for each of them before you do this. But once you have that step in place, the steps down here, editing a file called sshd_config, turning off password authentication, and then restarting the SSH service are all you need to do to make this happen. Let me show you that over on the Linux Lab system. I'm going to bring up sshd_config, and if I scroll down to password authentication, it's currently set to yes. I know that all the users on here can log in with SSH keys, so I'm going to change that to no. When I write that out and exit and restart SSH, sudo system control, restart SSHD. From this point on, I will no longer be able to log in with a password. So all of those people who are connecting up and thinking, oh, let me just try all these common root passwords, and I'll just keep trying them all day long and all day long and all day long, from this point on, they're not going to even have a chance to try password login. It's a very easy way to do this. The other thing that you can do is say, hey, root isn't allowed to log in at all directly anymore. And that's the same process. You're editing the same file. You're modifying a slightly different line. So you change permit root login to prohibit-password. It's probably set to yes right now because you need to be able to log in as root unless you got a different account. Restart SSH afterwards. By the way, that doesn't kill the SSH connections you already have. It just lets them, they will not get killed off. Once you've made that change, then root can't log in directly. You have to log in as lab user from that point on. But you can always change to become root with either the sudo or su commands. If you want to restrict access to SSH access to just a few IP addresses, I have a link to an article that talks about how to do that. And as for removing unneeded packages, go through the list of installed packages. If you see, I would start with the ones that have open network ports. Those are the highest risk ones. If you see some in there and you're like, I don't really want that listening on a port anymore, you can remove the package entirely. We've already seen how to find out which package owns a file. And once you found that out, you can use apt remove to pull that file out of inventory. That package is no longer there. That means that the program can no longer listen on that port once you've rebooted. Like I said, look for open ports, figure out which ones you need, and then for any that you don't need, shut the service down, make sure you do stop and disable, and then remove the package entirely if you don't need it anymore. There's one more step that you can consider for a Linux computer that's installed on a physical computer or a local virtual machine but not a cloud server, and that is encrypting the root file system of the entire Linux server. You have to provide a password that's different from the password you log in under. This password is used to encrypt every single block of data on the hard drive, all of them. And because that's put in so early in the process, you actually have to connect up and type in that password before you can finish booting. That means you don't even have an SSH server. You have to do this on a console. And because that is tricky at best for a cloud server, they don't generally offer this. But it is available in the install process if you're creating a virtual machine or if you're installing this on a physical computer. It's not all that complex. The process is handled for you. You just have to make sure you've got that password in a safe place, because if you forget it, you can't get access to that system ever again. There's some more notes about package management and updates, and I've got a few advanced topics that you can consider in the future. We may do those in some future webcasts. I would like to switch down to common problems, and I do want to go through just a couple of these pieces because I think these are valuable things to know. First off, when you start running out of drive space, the computer doesn't really tell you. It just kind of says, well, I'm going to keep going until I'm so totally full that I can't do anything. But it doesn't really tell you that something's wrong. So you have to check yourself. DF-H, disk free, remember we saw this earlier? This tells you how much disk space is used on each of the partitions. Ignore these ones down here that say 100% full because you can't write to these. These are part of Snap, and those are separate. But the biggest one is the root file system and anything that you got for individual partitions for things like home or var or user or opt. In this case, we're only 10% full. That's great. That's the first one to check, but there is one more that you should also check when you're trying to say, hey, is maybe my drive filling up? And that's df space -I. This doesn't look at the amount of free blocks of stuff on disk. It looks at the number of inodes. Effectively, how many files do I have on disk? It's a little more subtle than that, but that's pretty close. And in this case, I have a limit on this particular system of 6.5 million files, and I'm only using 166,000 of those. I'm only 3% full on inode. If you've got a lot of normal files and big files on the disk, you won't ever fill this up. If you've got a ton of really small files, you can actually run out of inodes before you run out of disk space. And so you have to check both of these, especially if you get out of disk error, can't save file, can't open this other thing, and you look at the free space and there's tons of it. Make sure you come down and run this df-I command as well, just to make sure, because you can get into pathological circumstances where there's tons of free space, but you can't write anymore because there aren't any spaces to hold any more files. Okay. The next one is if you start running low on space, well then where is the offending content? What's filling up the drive? How do you figure that out? Let me clear the screen so it starts off fresh. du-sh lets me look at how much space is being used. Here we go. Sorry, it's complaining about permissions. That means I forgot to put sudo in front of it. du-sh. This says, look at all the top level directories. And would you please tell me how much each of them are using? du-disk usage -sh says, show me a human readable summary of each of the top level directories. Let's take a look. Because I'm doing it with sudo, it has permission to look all the way down the drive. It may still complain about a couple of things. Yep, there we go. But this is what matters to me. Notice 145 meg in boot, 8 meg in Etsy, 55 meg in home, blah, 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 blah. A gig in snap, then not to worry about. Oh, here we go. 2.2 gig in user, 2.1 gig in var. Now, this isn't a full drive, but if it were, then I would start off with a couple of drives that are the worst offenders. And so I would definitely look into user. Let's go and redo this. Sudo du-sh/var /*. Let's take a look and see which directory is holding the most content there. This came back very quickly because everything's in cache. Oh, look, my log directory is 1.5 gig of those. And you can keep working your way down to find out which directory is filling them up. Okay. Let's take a look at a couple more common problems. I can make a network, I can ping things on the internet, but when I try to look anything up, I can't do it. This is actually a relatively straightforward one. DNS lookup is controlled. I'm going to clear the screen again so we can start up. Fresh. And I need to look at the file let's Etsy resolve.conf. RESOLV. There's no E at the end of it. Resolve.conf. This shows me what IP addresses are being used to do DNS lookup. I'm querying three things: 8.8.8.8, and then 2001 blah 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 8888, 2001 blah 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 8844. Those three computers do DNS lookups. So if I can't look up whitehouse.gov or stearns.org or whatever, then I can always come back and check and say, can I really do DNS lookups for each of these? Here's how you do it. We're going to place a query to one of those machines. Dig plus short at 8.8.8.8, which is one of my DNS servers, www.whitehouse.gov. You don't have to put it there, but it's more accurate if you do. And I want to look up the address record for that. When I look that up, I get, here's these other names for it, but here's the actual target IP address I'm going to get to. That's great. That worked. Now, let's say that in that file we had an entry that wasn't working. So let me try dig plus short at 75.75.75.75, which is Comcast's primary name server. Note that I'm not on Comcast's network, but I'm going to do that DNS lookup anyways, and nothing comes back. So this is my way of saying I don't want to just randomly pick one of those servers. I want to pick a specific name server. I want to place a specific query. I want to know exactly what that name server is giving back to me. This dig command does that very well, and it helps you diagnose things like DNS lookup errors. So if my resolve.conf included 75.75.75.75, that would let me go back into that file, take that line out, and say, stop asking that DNS server. It's not able to respond to us, and that's why lookups are taking a long time or don't work at all. We already talked about ping and checking network connectivity with that. The only thing that's a little different you might consider is that if you're pinging an IPv6 address, you'll have to use ping 6. It's a slightly different command line depending on the IP, whether you're pinging an IPv4 address or an IPv6 address. Okay. When you're looking at what you think might be problems with the system, if something is seriously going wrong, the kernel's screwing up, a drive is dying, a network interface is going down, you've got bad RAM, you're just getting weird effects all over the place, use the dmesg command, and I'm going to do sudo dmesg pipeless. This gives me a long summary of messages that the kernel provided. When you first boot up, you notice how the timestamp here is literally 0. This is just after it booted. These are the boot messages that the kernel would have put up on the console if there was one, talking about what hardware it's found, how it initialized so-and-so, it turned on this feature, and so on. When you get down towards the end, I'm just going to scroll through really fast, we get to some more esoteric events. And so if you're having trouble, interrupt took too long. Well, that's interesting. Why did that happen? It could be this is something to do with the cloud environment that I'm in, that the host was having trouble and it wasn't giving my virtual machine enough cycles. I need to go back to Google and say, okay, what causes this problem? dmesg is really handy for those, and also for the boot messages that you get way up at the top of that output, because you can then very, very specifically go down and say, was this device detected? And if a device that you think is supposed to be there isn't showing up, then that's where you want to go and say, okay, the kernel's not finding it. Why not? Now, there are also other logs, so I do want to make sure you know about those as well. If I go to /var/log, what I get are the log files that this system's creating. So if I do tail-f/var/log/syslog, well, that's interesting. Sudo tail-f/var/log/syslog. Ah, that's better. Great. I need to be root to read that file. Now I see the log messages for the things that I've done recently. And so this tells me when I am shutting down a service or starting a service, or if somebody's run different commands. There's also one more, and this one is auth.log. So if I sudo tail-f/var/log/auth.log, these tend to be related to logins and people trying to connect. And you'll see, for example, people trying to log in and brute force passwords with SSH. Those will show up inside. Invalid user ZH. I don't remember setting up an account called ZH. So the person at IP address 106.124.137.103 is just trying to guess passwords and see if he can get in. This is why I suggest kind of limiting SSH down to just the IP addresses that need to get in. All right, we're almost ready. The last one that I want to show you is LSOF, and this is list open files. So if I want to see what programs are holding files or connection open, this is the big hammer. Sudo lsof-n pipe less-s. And this gives you this massive listing. Over on the left-hand side is the individual command. Here's the process ID that it's running under. And if you scroll over to the right, you see every file that's being held open, and that includes network connection. So Bill, if I go, yes.
I'm sorry to interrupt, but there's quite a lag on your presentation screen. Your live video is fine, but your presentation screen is quite a bit behind.
Okay. Does it kind of generally catch up, but only about 10 seconds later or a minute later?
Yeah, well, it may be 20 or 30 seconds at this point. Right now, I see on your command line, I see sudo tail with the F flag and then var log off.
Got it. So hey, very sorry about that.
Oh, no problem.
This is, yep, the sad as I am to say it, we're actually reaching 4 o'clock. So it just, I think in the end, I won't be able to do a live demo of this one. Over in your lab notebook, we've got sudo lsof-n And I show you how to save that out to a temporary file. And then you can look at that file, and I give you one other filter that throws away a bunch of library output that isn't all that interesting. LSOF tells you what files are being held open on your system. So if you're looking for which program is keeping a directory locked, or if you have a file that you want to see which program is working on a given port, it's a very low-level way to do it, but it's a nice one to have in your toolkit. So as much as I hate to say it, we've come to the end of the normal time on this lab. And so I think we are going to have to skip some of the advanced topics that I've got down below. I hope you'll take a look at strace and just run some commands underneath it. You get to see the individual tasks that those are doing. Ansible and SE Linux are also two very important ones to kind of learn about how to use. SE Linux is not enabled on Ubuntu, and Ubuntu, don't believe it's enabled on Debian. It tends to be enabled on the RPM systems. And I've given you just kind of the basic tools for understanding those. I'm sorry we couldn't get to those advanced topics or the sections that we skipped in the middle. What we may do is come up with another time slot, perhaps, Jason, and consider finishing this up at some point.
Sure. Yeah.
All righty. I'm going to kill the screen share because apparently it's about 3 weeks behind. And nobody needs to see that, I'll tell you.
Well, hey, at least it waited until the last few minutes to kind of get laggy there. So.
Yeah, sorry about that. I'm not quite sure what happened. Hey, I've got to give a second thanks to everybody who took part in this. It really is not possible to do a lab like this without people in the background who are answering questions. Thank you so much to the people who gave up their time today. BB, Brad, Deb, Jason, Justin, Keith, Naomi, Ryan, Sam, and Velda. I really can't thank you enough for being willing to help out because this could not have been done without it.
Well, thank you for this awesome webinar. So.
Mm-hmm. Yes,
Yep,
it
thank
was
you.
my pleasure.
Nari, I think that's how you pronounce it, said, called you Uncle Bill for your, thank you, Uncle Bill, for your time and awesome presentation.
That's adorable.
I do have some people who call me Uncle Bill, including Chris Brenton's kids when they were younger. I was yes. Uncle Bill. Oh, what a sweet little kitty. Yeah, you're a photo bomber if I ever saw one.
Yeah, absolutely.
Yeah. All right,
any
everybody.
Other questions that came up that should get covered before we finish up?
For the most part, they were covered throughout. The GoToWebinar team was just on it, covering as much. Really, any question we answer at this point would just, I think we need another session.
That's good.
Bill, what we'll do is we'll send you all the kitty. We'll send you all the questions that were asked, so that way you can take a look at what we can potentially add to either a second session or a revised one of this. To everyone else, go ahead.
I was just going to say there was one question. Somebody asked, are the default logging settings in Ubuntu adequate, or should they turn them up or down?
The logging settings are fine. The one thing we didn't cover this specifically, it was logging remotely. You've only got one copy of those logs. If somebody breaks in and turns off logging and deletes your logs, they're all gone. So the best approach is to come up with a centralized log server, forward your logs from all your systems to that. Don't allow logins or any other services on that log server. And that way, if somebody breaks in, deletes your logs, you've got a second copy remotely. There are lots of how-tos on the internet for how to set that up. And if something doesn't work, come on back to live chat and we'll have some more discussion about it later.
And if you ever email webcast or training at Wild West Hackin Fest, Deb is the one who responds. So be kind and nice to her.
Thank
Absolutely.
you. They are very kind, very nice. Yeah. Also, Velda is on that as well, so be kind to both of us.
Of course.
And if you ever wondered what it's like to take training with Wild West Hackin Fest, it's like this, except with a lot less people, because we capped it at around 200. So today we had 800 people, so that'd be 200. The certificate will go up 24 hours from now, so be on the lookout for an email called certificate. and there's a link in there called My Certificate. You click on that, it will auto-generate a certificate based on the name that you gave us. So if you didn't use your name, that's the name that's going to be on there, which is a fun way to get like whatever your hacker handle or whatever it is you want added on there. Just register with that. And then the recording will be available in about 2 weeks. So we'll get in touch with Ryan. Deb, any final thoughts from you? Anything I missed?
No, just thank you guys for showing up and being kind and answering each other's questions. We definitely could not we couldn't answer 800 people's questions without you. So thank you very much.
Yeah. Bill, any final words?
Thank you for your time. We really appreciate it. We hope you got something out of it. Please continue the discussion over on the live chat channel. If you've got some things that we didn't cover and you feel like chatting with other people about them, this is what Discord is all about. It can't be one way. We want to give you a resource where you can ask those questions and continue the conversation.
That is true. All right, everybody. Thank you so much. We'll see you next time on another Hackin' Cast with the old Wild West Hackin Fest. Bye-bye.
Bye. Thanks, Bill. Thanks, everybody.
Bye-bye.
I am ending the webinar.